Okay, I think we should already be live. Maybe if some of you could tell me if the audio levels are all right like that. I have to say I haven't streamed in really a long time, and I've since switched to a new operating system from Windows to macOS. So I'm not quite sure if everything is set up correctly. But I will just depend on y'all telling me if this is working or not. Maybe I will open the stream on my phone on the side. Yeah, that's working good. Hi, hello. Okay, so I guess we could just get started. Hello everyone, my name is Andreas, for those of you who don't know. Yeah, we're doing this in English. Let's see how we will use this material later. So we thought that it might be better to make it in English, just to have a broader audience. My name is Andreas, as I just said. Maybe some of you already know me. I've been developing web applications since 2015, something like that. And we started back then. I started developing in my internship with developing a data grid. So this is actually where the loop comes back to what we are doing today or this week. Back then, I was just tasked to move this project from the Excel world to the online world. And of course, since we wanted to give our user a familiar user interface, we just decided that it might be good to just provide them with a grid interface. So we built this data grid. Back then, we used AngularJS to get started, and we quickly noticed that performance is really a problem when working with large data sets, many visible data points at the same time, and AngularJS just wasn't made for such tasks back then. We quickly switched to React, our implementation. So we redid the whole project, we rebuilt it in React, and have been quite successful with this approach ever since. Recently, we discovered this kind of new framework, SolidJS, and discovered that it really is meant for such high performance applications and high performance use cases, while still being kind of comparable to the React world. So as a React developer, you should feel right at home inside of SolidJS, and there should not be many places where you have to rewire your mental model. As you can see, I already have the website open. Currently, there's this hackathon running, SolidHack, where the community wants to enlarge the ecosystem, so to say. So there's a prize fund of, in total, I think, $12,000, I think. Let's see, let's go to prizes. Yeah, we have 3 categories: best application, $5,000, best ecosystem utility, $5,000, and best student project, another $2,000. We are definitely aiming for the best ecosystem utility award. And we decided that we invest 1 week of our time to port or to rebuild a data grid within SolidJS. We want to use this opportunity to really rethink and rebuild what we've learned with building data grids. And so we are going to rebuild the data grid from the ground up within this week. And I hope we get far enough that by the end of the week, we can publish this data grid as a library. Otherwise, these videos will have to suffice as an application for this hackathon. As you can see, there are 10 days left. So I think for this week, we are really focusing on the implementation. Maybe I will have to add some days later after this week for the publication of the library itself, so that you can really use it in your projects. But we will see how far we are going to get within this week. Regarding questions, I'd like to keep those streams as flexible as possible. So if you have any questions, if you have any remarks, just write them in the chat. I have that open on a second screen, so that I can really I can explain something where I went maybe too quickly, or maybe you can point me to bugs or other logic mistakes that I'm doing. And since we are working right here for 30 hours together, so 5 days, 6 hours each, I I really expect there to be some kind of problems where I have to battle with some difficulties, where I'd be happy to get your feedback and your help there as well. Okay, so as I already said, for this hackathon, we want to build a data grid library. So we want to build a library that others can use, where they can display lots of data. Before we get started with implementation, let's first talk a bit about goals. So what do we want to achieve? Of course, we want to build a data grid. Let me zoom in a bit here. Just tell me if anything is not large enough. So we want to build a data grid. So we want to display many data points. So maybe when we're talking about the data set sizes, I definitely want the grid to be quite responsive for something like 10K rows. But I also want to try out larger data sets, maybe let's say up to 100K rows. And maybe the same can be said about the columns, so maybe not like 10,000 columns, but a few hundreds of columns should absolutely be no problem in our implementation. So those are the goals for me that I want to achieve. When working with those kinds of grids, we oftentimes battled or discussed about whether this data should be handled and calculated client-side or server-side. Really two different approaches. When doing this server-side, the aggregations, the filters, etc., then of course the server will be more on the load, and the client has to wait or wait for feedback from the server, as to send many requests back and forth between client and server. So that back then we started with a client-side data grid. So the grid itself downloads all this data, saves it inside of the grid in memory, and then does all aggregations, all filters, all sortings in memory on the client side. I think we want to build parts of the grid in a reusable way so that we can later use those parts for our server-side grid. For server-side grid, but so far we will focus on the client-side specific things, just so that we can throw some data in there and quickly get a look at the data. So this will be quite a lot easier for stuff like multi-select filters. In a server-side grid, we have to implement an endpoint or some kind of a protocol for each of those columns, where we can ask the backend what values are present in that column, so the backend can send us the values for the multi-select back. And we will just do that in a client-side way, so we can inspect the data and extract all unique values from the data, so that we can display it, for example, in multi-select filters. So let's first we are going to focus on the client-side interaction. I already talked a bit about performance, so we have quite large data sets, and when we are doing calculations on that many data sets, it can happen that these calculations take longer than 60 milliseconds. 60 milliseconds is basically the budget that you have for one frame. So normal screens refresh 60 times per second, so you have something like 60 milliseconds per frame where you have to do all your calculations. But when handling large data sets, and when we want to be flexible enough to handle even larger data sets, then it is quite possible that we are going to bust our frame budget. This is why I want to experiment. I'm not quite sure if this will work, but I want to experiment with chunking my calculations, chunking my computations, so that I can yield to the main thread, so that other animations can still run, other interactions can still run, while I pause my calculations for just a very short amount, so that I can then later continue where I left off. Maybe as you already know, the web itself is always running in one thread, where we can, I don't want to make an example, So when we have a calculation, for example, a while loop that is running for 5 seconds, then the page itself, the user interactions will be frozen until this loop is done. And this is something that we want to avoid when building our grid. So we want to take this data and split our calculations in tiny chunks so that we are not blocking the main thread. So stuff like animations and interactions are still allowed to run. For bundle size, this is not really a concern, a concern that is too large for me right now. I will just first build a first version, and then maybe we can optimize it later. But we will kind of ignore the bundle size for now, just because we are working with lots and lots of data. So this loading of the data will be what makes our application slow, I guess. So loading another 100 kilobytes of JavaScript might not be the deal breaker for users of our application in the end. So bundle size, we will not be too focused on that, but I definitely want to take a look at how many dependencies I pull into this project. So I really want to keep that lean, but we will have to see how we are going to build stuff like popovers, drop downs, and stuff like that, because I don't really want to build those myself in this project. But we will have to see what we are going to use then. Maybe for styling, I really want users of this library to customize the look and feel of the application. So I want to expose simple class names that others can just override via their CSS and JS or SCSS solution of choice. So I don't want to force users into some kind of a JavaScript library or stuff like that. So we will just be using simple SCSS files, where we'll just be using class names, and we want to keep the specificity low, so that users can easily override our styles that we supplied, so that they can really customize the application. What I mean by that is, let's say I have a grid cell, then I don't want to style this cell with nested selectors like grid, grid body, grid cell, because then I have 3 classes to target this specific cell, and everyone who wants to override styles that are supplied there has to provide 3 classes as well, at least 3 classes as well. So just as a rule of thumb, I want each element to be targetable with 1 class, so no nesting. Of course, if I have some kind of modifiers like disabled or collapsed or stuff, or expanded or stuff like that, then we will have to add this modifier to the class. But everything else should only be targetable by 1 class, so that users can really simply override our styles and not have to fight with our provided styles of choice. Maybe we will build it in a kind of separated way, so that we have base styles for the positioning of our elements and stuff, and maybe then some kind of like theme styles that provide colors, paddings, and stuff like that, so that we can keep this flexible as well. So maybe users only import the base styles for the positioning, so everything that is absolutely required to make the grid work, and then maybe they can import theme-specific stuff as well. Okay, so we have styling. We will just be using SCSS files. To get started, I will be using the Wheat bundler. It's kind of the default for SolidJS projects. And as far as I know, it also provides a library mode so that we can bundle our code as a library and publish it later. But again, this will be pushed back a bit. At first, we will be developing this library within a normal project and then extract the code later. Okay, so yeah, we have the bundler. Of course, one very important point for me is Typescript support. And there's really not much choice for me. We are going all the way with TypeScript, so we want this to be a type-safe library where you cannot make any typos when referring the items or the rows inside of the grid. So this is very important for me, and we will really be careful not to introduce any type unsafeties there. We will be using the strictest compiler settings of TypeScript so that we really can catch those errors as early as possible. Okay, anything else? So we have some data performance requirements. We will be focusing on client side by splitting the calculations to not block. Styling, we got the bundler. And maybe let's talk features. Maybe let's just add something like up here. When we want to render 1,000 or more rows within the browser, then we cannot only rely on the browser. If you've ever rendered an HTML table with like, I don't know, 200 times 200 cells, then you might have already felt that the browser itself cannot handle that many DOM elements to calculate the layout. So there we definitely have to use virtualization, which means that we will not be rendering all cells at the same time, but we will only be rendering the cells that are visible at one point in time. So there we have to see if we will build our own virtualization library for columns and rows that we can then reuse for our data grid itself. So this is another very important point. Somebody in the chat asked for testing. We will see if we have some really domain-specific parts where we have to do calculations and computations. Then I definitely like to use testing. If it is the case, then we will use vtest.dev. Really fast to set up, really fast to run the tests. API is kind of like Jest, but it's just integrated with Vite and the bundlers from Vite, so it's running much, much quicker. So if we have any computations there, then we will be using vtest. But I don't think we will have enough time to add end-to-end tests to the grid within this week, but who knows. But of course, for computations, calculations, for example, if a row is in the view currently, then we might be using a library like vtest. Will you provide APIs for end users to test if their business use case work in your data grid? Could you maybe explain this question a bit more? I'm not quite sure if I completely understand your point, but it sounds interesting, definitely. For their components. I think this library will be low level enough to work with the data. And I want to expose the, so to say, controller of the grid itself so that you can imperatively access lots of the stuff inside of the grid. So something like scroll to row, scroll to column, or something like that. Maybe we will also expose some functions to access the data of a cell, but this will definitely not be a priority, but is a kind of a cool idea that I want to write down for later maybe. Test controller to access data UI in a programmatic way. This could be quite worthwhile, as you said, if products write tests for themselves, that they can access the data within their grid to make sure that the correct calculations are being made within the application, to make sure that they configured the grid correctly. Because this is something that I definitely can promise, this grid will have different kinds of features so that the API will become quite large. Of course, we want to make sure to separate the different concerns into different places in the API, but there are still many places to configure this library, or there will be many places to configure this library. So having the possibility to write tests to see if you have configured it correctly might definitely be something that is worth our time. But we will have to see how fast we are getting through this. Okay, then maybe let's talk features. So of course we want to display data in a grid. We want to have pinned columns and pinned rows. So when you're scrolling to the left or the right, we want to have columns that are fixed on the left side and I think fixed on the right side. We will see if we can build some kind of pinned rows or sticky rows so that we can, when you scroll, that rows are attached to the top of the grid. This is something that I really like to experiment with. Of course, we want filters and sorting in our application so that you can select a column, click on the column header, for example, and then add a filter there, maybe a multi-select filter. And we want to keep the interface as flexible as possible so that we can easily extend those filters, or so that users of our grid can extend those filters. So maybe one of the filters. Rendering and filtering logic, so that maybe we will just add a simple multi-select filter and other users of the library can then add their own number range filter or a search filter or something like that, and implement their filters by themselves. So we want the filters to be customizable. Another very important feature is grouping. So simply displaying rows of data is not that interesting. What is really much more interesting is grouping the data. So for example, let's say you have a grid where you want to display all your different articles that you are selling on different platforms, and then maybe you want to group those articles by their product category, for example, so that you can then compare the different categories and really get insight into your data. Because displaying 100,000 rows to the users, it's kind of nice, but nobody is looking at every one of those 100,000 rows. So we have to supply features that help the user explore the data in a much quicker way. Like, for example, grouping the data for different fields, different categories, so that I can access the information that is hidden within the data much quicker. Grouping also means that we want aggregations. So that you can maybe have a column where all values within the group are summed, where they're averaged, mean, min, max, etc. And again, this should be something that is extensible, so the grid itself does not come with a predefined set of aggregation functions, but users should be able to supply their own aggregation functions for their columns. Let's see. Okay, now we can group. Another point that has come up quite often for us is it's quite natural for users to imagine the groups not being balanced. So for example, let's say you have product categories and then you have e-commerce, maybe electronics and food, for example, because you have an online store where you're selling food and electronics. And now maybe you say, okay, in my electronics category, there are one subgroups like mobile phones, mobile devices, on-premise devices, larger devices, or something like that, or entertainment units. So maybe you want your grid to be able to group this data differently regarding the category. So first you group by category, then you have two group rows with electronics and fruit. And then when you expand the electronics, then you have different subgroups, while when you expand the fruits, then you directly have the child elements. This is something that I'm not quite sure about yet. It's definitely easier for to understand, I think, to have the trees balanced. So to say, okay, the first grouping level is always the category, and the next grouping level is always the subcategory, to not have some conditions there that when the first category is A, then the first grouping level should be B or something like that. But we will see. Maybe we can come up with a cool idea or cool API to make this possible to have imbalanced trees. But the balanced trees is definitely something that we want to have in the end result. Okay, what else could be interesting for a data grid? We want to group our data, we're going to aggregate data, filter, sort. Anything else? So one thing that has come up quite often for us is an Excel export. Or copy-paste support, which would mean we have selection as well. This will definitely be something that's quite complex to accomplish in a way that it's also interactable with the keyboard, for example. Because when you select a cell, then you want to move cells with the arrow keys. You want to maybe hold the shift key and press the arrow keys to increase or decrease the selection. So this is something that might be quite complex, but we will be keeping it in the backlog because it might be a quite interesting feature. Okay, what else do we want inside of our data grid? We have grouping, we have filters. So something like charts would be quite cool to have inside of there as well. But this will, I think, be something that we are doing a bit later. So when you already have this logic to aggregate data, to group data, then you can quite easily generate charts from that as well, because having a bar chart with the sales per category is just a different representation of having two group rows showing the sales of different product categories. So there we will have to see if there's time in the end, then we will be doing charts as well. Maybe something with regards to virtualization. We noticed for our use cases that when you have a very large monitor and you are displaying many cells at the same time, then scrolling can become quite performance intensive, because with each scroll, lots and lots of cells have to be displayed at the same time and have to be updated at the same time. So there maybe we will add some kind of a feature where the grid maybe renders a cheap pass at first, just to get something on the screen quickly, and then only in the full pass, maybe interaction elements like tooltips or buttons or inline charts or something like that will be rendered. And then users of the grid application can then decide if they want to do everything within the cheap pass or if they want to make use of the full pass render if they need it. Okay, anything else? I have thought about this in preparation for this, of course, as well. Maybe we will just copy. I will just take a look at the notes that I have made previously, just to make sure that I did not miss anything now. Groups, calculations. Yeah, of course. The columns itself should be resizable. Let's do it like here. So that you can just drag and drop the width of a column to make it larger and smaller. This is something that I'd like to apply. Maybe we will provide some editors so that you can edit data inline. But I think this should be it for now. Okay, now we have a list of features that we want to build within our grid component or data grid component. Then maybe let's build a small timeline for the week so that we can just have some small sub goals that we want to achieve to get a feel a bit how we are progressing through the week. So let's just insert a table. Let's add the week there. And now let's discuss what we want to do today. Of course, goals. Non-goals is something that we have done right now. So for example, the focus on client side, so the server side aggregations and server side computation is definitely something that might come later, but it's definitely a non-goal for this week. So we have goals and non-goals for today. And then we want to talk a bit about the architecture or interface of our grid. Maybe this is something that's quite important to do before we get even further, because it kind of defines how we are approaching this. And my first instinct was to basically handle the virtualization part itself at first, so that we have an interface that can just display tons of tabular data with any kind of approach that the user wants. So some aggregations or groupings, doesn't matter. At first, we want to have this pure virtualization approach. So build virtualization library. I don't think the skeleton component will be required, and SolidJS does not have something like that in comparison with Angular. So we will not be providing schematics or generators. We will have some examples in our in the README, in the documentation in the end, and I hope that we can make the interface as small as possible for the 90% case, while offering many extension points if we want to customize the behavior of the component, so that the skeleton, the first start should be as easy as possible. So first we want to build this virtualization library. We talk about approach. Maybe this will in the end be maybe a virtualized table. And there we want this table should just be the full size of its parent container. So you somehow have to specify the size of the grid. And I want users to be able to specify the size with the pure CSS approach, while the grid just fills every space available. Yeah, one more thing. Maybe let's add it up here. We will just be supporting evergreen browsers, so no Internet Explorer. We will be using many modern features that make our life easier, like the resize observer, for example. And we don't really want to support Internet Explorer for now. Okay, so the table should autofill available space. We, as users, we should only supply number of rows, number of columns, and some kind of a cell component, where the grid passes in all the data required in the cell, so that we can then render a header cell, a grouping cell, a chart cell, or anything that we want. But the grid itself, the virtualized table, will just provide a very simple interface just for the virtualization of data, so that we can then layer the logic of our grid on top. So we have this lower level primitive that we can use to virtualize the table, virtualize large amount of data, and then we can add another feature on top, or other features on top. Then we have the grid itself. And at the heart of the grid will be our items, so the item that we want to render in the grid, and some kind of column definitions, columns, so that we can have definitions for all the columns, then provide options for each column, maybe provide options for the items itself, so that we can then later add those features if they are column dependent or if they are dependent on the whole grid. So for example, grouping is definitely something that's living on a column. So we have one column that is groupable, while other features might live directly on the data grid component itself, like maybe the aggregations, or aggregations are also column dependent. The copy paste might be a grid dependent feature, Excel export, stuff like that might be living on the grid itself, but we will be pushing lots of the configuration stuff down to the columns itself. Okay, so I think we might be able to get quite far with the table virtualization library today. Maybe we will be even able to finish this for today, so that we can then really start with the base setup. Tomorrow, where we can set up the controller, the place where the logic is pulled together, where we can add more computations, so that we have a place where we will be putting the other features in the other days. Then. Okay, so we have the base setup for the data grid. And I think the first real feature that we want to add is maybe the groupings, even, because the groups are quite a low-level feature. Maybe it's just sorting. Sorting is a bit easier, I think. Maybe we'll start with sorting. Filters. And what else did I have in my list? Oh, resizable columns are quite interesting as well. This might fit into a single day, I think. Filters. Yeah, then we have the groups, filters and groups on Wednesday. I think this is quite an ambitious goal, but we will see how quickly we get through this. Then we can add aggregation. This should be quite easy, I think. And then in the end, I definitely want to have some kind of automatic generation of column definitions, so that you can just push in a large list of objects of any shape, and the grid will just kind of figure out by itself the column definitions, so that you can get so this would be something that you can use to really explore new data sets. So maybe you could even just upload an Excel file and display it within this grid, just to get a quick look at the data itself with all the features that the grid provides. Okay, I think this will be just the rough plan for the week. And I'm really excited to see how far we will get along. I think components like tooltips and menus for the header menus, for example, this will be something that will be taking quite a lot of time. So maybe we will just be using something like Solid Bootstrap, I think, for those base components. But we will always be aiming to make those components interchangeable. So when users don't want the dependency in React Solid, so they can then provide their own components for the menus, for example, or for tooltips and stuff like that. but we will see how far we will we will get within the week. Okay, so this is the goal for the week. We are building a data grid library. The core features, grouping and filtering of really large data sets, so tens to hundreds and hundreds of thousands of rows. Virtualized columns, so that we can have hundreds of columns as well, so that users can quickly iterate or explore the data. And this will be, I think, it for the core features of the grid that we will be building within the week. Maybe let's take a look at some other grid libraries just to get an inspiration. Yeah, AG Grid is something that's used quite often. Yeah, you have sorting with these animations. I'm not quite sure if we will be having animations within our grid. Yeah, we have this pin feature as well, so that you can pin a column to the left and scroll. We will be trying for that as well. What else can we do here? Ooh, this is cool to just have this drop down of columns. Maybe let's hide all columns and then just add single columns to see what's happening when we add those. Ooh, those animations are kind of cool. Yeah, of course, yeah, they have filters. Yeah, those filters are really cool. Greater than 10. And now we have a filter in here. It's a bit noisy for you. Of course, we can zoom in a bit, I think. This is something that might be quite interesting. Let's see what else they can do here. Wait, it's small again. Ooh, they have inline editors here. Oh. This is interesting. So they have renderers for different kinds of content. So by default, when there's a boolean within the cell, they just render this checkbox. But this has to be something that is extensible by the user, because let's say you want to have a button so that you can toggle the checkbox directly without setting this to false by yourself. Interesting. Okay, so this column is already in a number mode. Interesting. Oh, yeah, so here they have aggregations, so maybe we can aggregate all June values like that. And now we have nothing. Maybe can we group by nowhere? Group by country here. So now we have this group, and now we have the aggregations in our column. Okay, this is working. Let's pin the color, the country. So yeah, this is something that this is basically the aggregation that I'm aiming for as well, so that it can expand rows, collapse rows, have aggregations for the values. So here we have the sum of all values. They have this multi-edit, multi-select thing right here. Copy paste, I think, should be working as well. Let's just copy something. Yeah, it works perfectly. And I really want users to be able to use something like that here. They have some status rows, and I really want users to decide if they want this the status row, so that I can add own elements to the status row, for example. So to really offer flexibility there with a declarative interface. So I'm thinking we have a grid with the grid controller, so a grid context with all the logic stuff, and within there we have the grid itself, the data grid, maybe grid head, grid body, Then we could add a grid status row. We could add controls at the top for stuff like groups or filters here, something like that. You can edit the groups. This is definitely something that I want to try as well. Maybe let's look for one more example. Create data grid. Yeah, you're finding the AD grid implementation, of course. Yeah, here you can definitely also see the virtualization as well. So when we are scrolling fast, then, okay, this is maybe, I think it's better to see when we zoom out a lot. Yeah, so then we can see that the grid itself tries to keep up with the scrolling while rendering the elements in the background as soon as possible. So when we quickly scroll here, then we can see a blank screen for a second, and then the data comes in at a later point in time. Okay, here we have the sorting as well, export as well. We can't select cells. Oh, this is cool. Column spanning is something this might be interesting as well for the virtualized table component. This might be really interesting to have something like that. I think with rows, it's even more interesting. I'm not sure if they have row spanning. Reordering scroll to row, tree view. Ah, yeah, here they can expand rows as well. Master detail. Ooh, this is interesting. A whole subgrid within the outer grid application. This is definitely interesting as well. Yeah, here they have grouping as well. And here you can see what I meant earlier with the balanced trees. So here you always have the first group being the country, and then within the country you group by year. And you don't have the possibility to say United States is not only by year but also by month, because maybe it's a bigger country, I don't know. So this might really be something interesting, but so far I cannot really imagine how the user interface for that looks like, because having this global view on the groups is really beneficial in my opinion, and you lose that when this is no longer a global concern, but you only say, okay, below United States of America there should be groups by year. So then this option year has to somehow live within this grid row. It has to be displayed somewhere here, which is something that I'm not really sure how it could be implemented in a user-friendly way. A million cells. Yeah, here they have 1,000 columns and 1,000 rows. So this is really an order of magnitude that I want to reach as well, with a million cells, which it should absolutely be something that is achievable. So this is something really interesting, variable row height. So maybe let's just take a look at the virtualization here so that we can take a look at that. Let's zoom in our DevTools a bit and increase the screen size even more. Oh, this is interesting. They are using a CSS grid to order the grids within the cells within the grid. So they have this grid right here, and then they are rendering all those different rows here. With display content, so the rows itself are just for the positioning, and then there are the grid cells. So maybe let's just take a look at this cell. So we have this cell right here. And maybe let's scroll somewhere here and look at this cell. So we have this cell right here. And we only have the cells with column 25, 24, 23, column 20. And the column 19 is just not there. Because right now only these columns are visible on the page, and only when I start to scroll, then we can see down here that column 19, column 18, column 17 start to appear. Same thing when I scroll to the right, then the columns disappear. So for this virtualization, you have to be able to map the scroll position to the currently visible columns and rows. This is quite easy when you know the width and height of each column or each row, or so of each cell, because you can just calculate it. So for example, if we have 1000 rows and know that each row is 20 pixels in height, then we can simply calculate which rows are visible when we scrolled 500 pixels to the bottom, for example. However, when the different rows have different heights, then you suddenly cannot calculate this, but you have to go through all of the rows and sum up the dimensions. So this is a much more expensive task than to just than just being able to calculate the size of the rows. But this is really something that has taken us flexibility when working with our data grid, because in our data grid, in the grids that we have built so far, the dimensions of the rows has always been static, so that you can easily calculate the dimensions of the elements. And this might be something that we are going to try to keep these dynamic. So that we can vary them. So for example, a group row is larger or smaller than a non-group row, or so that we can maybe even embed something like, where was it? Something like a subgrid within the grid itself. So this is something then you have to define the size of this cell as much larger than the other group cells. Or the other group rows, so you have to have a dynamic row height for these features to work. This is also definitely something that our Virtualized Grid has to provide, so that we have a feature so that we can imperatively jump to rows or to columns. Oh, they're even scrolling there slowly. This is quite cool. But this is something that I definitely want to support as well with our component. Okay, I think this should be enough input. We have not really added much other than the dynamic row height. So this is definitely something that we might want to try as well. But other than that, groups, filters, sorting, and collapsing and expanding of groups are really the core features of our grid that we can use to get started with something. Okay, I'm actually quite happy with that so far. So we have spent the first hour of our stream to get started with the goals, the non-goals of application, the different features of our data grid, and we have made a very rough time frame for the upcoming week. Which should be enough to get started with the first version of our virtualized table. So I guess now is the perfect time to jump into source code. Let me open my folder, my development folder. Development, new folder, SolidHack. First, let's take a look at how we can bootstrap a new Solid project. take the documentation. No, not these documentations. I think. No, not the tutorial. Yeah, getting started. That's what I'm looking for. Okay, this is just a simple template project that we are going to use. Yeah, they're going to use the Vite template. Let's just do that. So let's open a terminal. This is definitely too small. And now just clone our new project, SolidHack. Maybe we'll just call it Solid Data Grid. Okay, in here we have our new empty project. They're using PNPM. I think we will just be sticking to Yarn. It's what I've always been using. I always wanted to try PNPM, but this is not something that we want to try today. Yes, exactly. The PNPM log file can be removed if I want to choose another project, another package manager. Let's take a look at the config file. So we have our Typescript config. And just a quick question, is the source code large enough or should I zoom in a bit more? Okay, no comment. So I just guess it's already large enough. So we have our target, yes, next, as I already said. We don't want to target old browsers. And I think the TypeScript compiler itself is only used for type checking in this setup. A bit fuzzy, then we can zoom in a bit more. I think this is also something that we might not need as large. Wait, let's do it like that. Font, zoom in, let's do it like that. Yeah, we don't really need the UI to be so large. We only need the source code itself to be large. Yeah, this could be the stream quality. We will have to wait and see. Oh, okay, perfect. Because, as I just wanted to say, TypeScript itself is not really used for compiling in the setup, but Vite is being used, and Vite itself is using ESBuild under the hood. And I think ESBuild is just removing all type annotations, so the TypeScript settings are kind of irrelevant for the build process itself. Module resolution. JSX preserve is important so that SolidJS can take control over the JSX. And we want to have this no emit right here. This is okay as well. Maybe let's directly run a task. Configure task and configure a TSC watch task. So this will add in VS Code the new tasks.json, and maybe let's configure it like that. Run on, yeah, run options, run on folder open. So now whenever we open this project, this task will be run. This will just start the TypeScript compiler in the watch mode in a new terminal, and will use the problem matcher, which means that the IDE will take a look at the output and interpret the output to show the errors within our source code directly and within the problems tab. So this is really something that I'd like to do in my projects, just to have the TypeScript compiler run in the background all of the time, so that we definitely can never skip or miss any type errors. But first, let's install our dependencies. Maybe take a look at the Vite config. Yeah, those are of course red. Still, okay, now they're no longer red because my packages are installed. We have the Solid plugin. We have our target is next because we want to target modern browsers. I think this is good so far. What is he complaining about? Cannot find definition. Okay, this is just restart Typescript server. That's a problem because I installed the dependencies so late. But this should not occur anymore. And now whenever we start the project, we just simulate that with reload window. Then we get this new IDE, this new tab right here. That we just run the types compiler directly and oh god. This is interesting. So they're using they're using node types within Vite itself. I think we don't really need the Vite client stuff in our TS config. I don't really think we need those. Let's take a look at that. Restart running task. No, this is still the problem. Okay, the module CSS, okay, that is fine. That is fine as well. Oh, I think we need the node types as well in our project. Let's just try that. Maybe let's re-add this line. And add yarn, add and add node typings. Okay, that's much better. And now we have one small problem remaining because Vite, the Vite Solid plugin is using Babel under the hood and it doesn't have type definitions. I'm not quite sure. I don't really want to type check the Vite package itself, but I think it will always be checked because I'm importing it right here in our project. Quite sure how I want to handle that. I guess Babel core should already be added, right? Yeah, Babel core is already part of our project, so maybe just let's add that specifically. Ooh, and this doesn't have types built in, right? So we just need type definitions for that. Add types. Core. Whenever you have a scope package, you just replace the add with 2 underscores, I think, if I remember correctly. Yeah, that looks good. Yeah, perfect. Zeros. Perfect. This is what I wanted to see. Okay, so now we have a project that's running without any type errors at least. So this is something that it's kind of expected when you're working with a new framework. Of course, when you're working with something like React or Angular or Vue, you would expect the base setup to run just without any errors, without any problems, so that you can just get going. Since Solid is really still quite young, you have to expect or have to live with these rough edges that still exist at the moment. But this really is getting better over time. So not really a problem after all. So maybe now let's take a look at the package.json and start the project. Yarn dev. And here you can already see the favorite part of my favorite part of using Vite, 333 milliseconds on a cold start. So I just ran yarn a couple of minutes ago, never started the project, and already have my application up and running. Let's check if our console logs are working so that we can see if everything is set up correctly. I think this can be a bit smaller. This can be a bit larger. And now let's first check the index HTML. So we have a really basic setup with a theme color of black, shortcut icon. So we have this fav icon here for a solid application. We have a title setup, a no script tag, and our root element, and we directly reference the index TSX, which is possible via Vite. So Vite takes the HTML file as an input, checks all external links, and sees, okay, here there's an index, there's a TSX file imported. So we can just import that and bundle that in our application. So in here we have TypeScript. Of course, the browser doesn't see the TypeScript. And let's see, and it's in the console. For the moment, so a restart doesn't break everything again. Oh yeah, the zoom is already gone. Yeah, thanks a lot. Ooh, I think the font zoom, is this something that is... Let's take a look. Editor font size here. Let's try that. Yeah, this looks good, I think. Yeah, that's a good tip, thanks. So now we have the setting where we have the font size here, so that everything stays nice and large. So then we maybe add a prettier RC. And I think since we are going to be developing this mostly on stream, print width, we will be setting the print width to 60 so that we have not as wide of lines, so that we can still get multiple editors side by side. So we have more lines but shorter lines. Okay, it seems like we have this refresh reload in here, so I think every change in here should reload the page. Yeah, exactly. We see a small reload here very quickly, just so that we can globally add event listeners or intervals like this. And when we reload the page, since we just reload, we clean up the browser cleans up all old listeners or all old intervals and schedules the new ones, so we don't get multiple versions of our intervals by specifying this refresh reload here at the top. This is just our basic SolidJS entry point. So we have this render function where we say, okay, we are looking for the root element and rendering the app within this root element, the app component. And of course, console log stuff, which we really don't need. Then maybe let's take a look at the app component. Ooh, is that working? No, that's not working. Okay. So, yeah, you can, Vite is configured in a way that, oh no, let me add just one more setting right here. On save, forward on save, true, on save, action, code actions on save, code actions on save, organize imports. So every time we press save, we want our imports to be organized. So when they're out of order or something like that, we just hit save and they're correctly ordered in the way that we want, in the way TypeScript wants them to be. Normally, I really don't take a look at imports in my application because I just depend on TypeScript to add automatic imports, which is just much easier than always specifying the imports by yourself. So what I wanted to say is, So far, the application uses these CSS modules so that we can directly access the styles from our styles object and prevent name clashes. So the build tool in the background extracts the contents from this file and hashes each selector and adds this hash here to the class name. So when we are using the app selector, like right here, then we get this app app here, app class name, and this hash in the end, so that we definitely have no overlaps, no name clashes right there. Since we want our users to be able to override the class names, we want the class names to be stable, because if I now enter something right here, maybe let's change it to left, then we get this new class right here. So our users would need to change their selectors for this new class. So we are not going to use this in our application in the end. Okay, so now let's first remove code that we don't need. Hello world. Now we have our hello world. We can remove our app module. And I think we are going to be leaving the index CSS, just some global styles, margin removed, font family set to some defaults, which just look a bit better than the browser defaults itself. So this is something that we are going to leave for now. I think we are going to try to build it in a way that these styles are not part of our library, because we don't want to override some user styles, but we want those styles within our application, definitely. Okay, the logo itself, I think this is also the fav icon. Oh no, it's fav icon is something else. So let's just delete the logo. The fav icon can stay for now. We will change that later, maybe. Okay, so we have our index file, we have our app.tsx, and now we can write our first components. Now we want to start with our virtualized grid. As I said earlier, before we get started with our virtualized grid, we need to be able to write our component in a way that it always takes the size of its parent container, because our grid, we need to access the size of the grid in JavaScript, and we want the grid to always take as much space as possible. Or maybe we could even split that up. This is maybe a good idea. So maybe the grid itself just has to be virtualized table, has to be called with width and height. And if you want to get the width and height from your own components, then you can just use another utility to measure the elements for yourself and to use these values for yourself. I think this is something that I might try. Okay, so we could just get started with that part of measuring elements and rendering the grid. Maybe let's add a new folder, virtualized table. Virtualized table.tsx, and let's add our component export function virtualized table. So same as in React, our components are just simple functions that directly return JSX. I think I recorded virtualized grid because the grid itself doesn't really know about concepts like table header, table body, and stuff like that. So it's just a bit more generic. And we have our grid. Let's try to render that, virtualized grid. And now we have our grid right here. Zoom in a bit here. Okay. So now maybe just so that we can get an overview about the grid itself, let's add a style file here. Virtualized Grid. I think we'll be using SCSS. Oh god, I haven't written SCSS for a really long time. Virtualized. Let's do like that. And as I said, we want to keep the specificity low. So we will just be using this rep class once so that we can avoid typing this every time. And we'll be adding classes down here with the ampersand selector. Ampersand, is that the right word? The and sign. And we will be using the grid container like that. And now we can use this class name in our component. Solid virtualized grid container. Okay, this did not seem to work. Grid container, solid virtualized grid. The bundler did not add my because I'm missing the import, of course. Okay, yeah, this is what I expected. Vite by itself, it does not have a dependency on the SAS loader or on the SAS itself. So whenever we import SCSS, it directly asks us, yeah, SAS is not found. You have to add it yourself. So let's add the JavaScript implementation of SAS. Resave our file, and there's our grid. Perfect. Okay. Oh, maybe I need to restart the bundler. Yeah, okay, here. Now we have our border. Perfect. Okay, now I'm thinking, when you write libraries, I'm not quite sure how I want to specify the width of elements, because normally I would just depend on having this global box sizing border box like that. But I'm not quite sure if it's clever to depend on that when you're building a user interface library. And if you should add this style for yourself whenever you do something. I think we're going to try it without that. And whenever we set the width for ourselves, then we just will be using the box sizing border box ourselves. Because when we now, let's add in the props right here. Normally I would just write the props inline, but I have a feeling that these might become quite large and that it might be beneficial to export those so that others can directly import them when wrapping this library. So we have a width number, height number, and we have these virtualized grid props right here. And of course, this is what we wanted. And we have these arrows directly right here. So now we can use the width and height in an inline style. Like that. And now users of our grid can just supply the width and height directly right here. So let's just add with a kind of a small grid that we render in the user interface. Okay, so this did not work. I think in SolidJS, you need to add the pixels to the inline style. Yeah, we don't see the inline style right here. So we need to add the pixels right here. And now we have our grid. So maybe let's just use dimensions that are always visible on our screen for now, so that we have it a bit easier. Yeah, now you can see what I meant by talking about the border box sizing. On the grid container, we specified the width and the height to be 600 and 300 here on the left, but our dimensions add the border to that. So our grid is not 600 pixels wide, but it's 1 pixel border, then 600 pixels content, and another pixel border, so it's 602 pixels wide. So we will just be adding the box size in border box whenever we want to define the width ourselves. And now we can see that the border is reduced or subtracted from the width that we specified ourselves. So maybe let's do something to so that these class names are not that long. Maybe let's add a new folder. Lib. Virtualized Grid. New folder. Scoped classes. Class scope string, so that we don't have to write this solid virtualized grid dash every time we want to add a new class. So maybe we will just add these this scoped helper. Define scope. Maybe it would be cool to be able to pass in more than just the class name itself, but also some objects or lists of classes or something like that, while being able to depend on it that all those classes will have this scope. I think I like that. Let's do it like that. Let's be able to add in many classes for now. There we can add the scope. Add the dash dash. No, I don't think I want I want users to supply the dash dash by themselves, just to be really specific. But I think I will be using low dashes, because low dashes are can be used in variable names. We'll take a look at that in a second. Class name. Maybe we filter first. Oops. No, undefined false. And now we can add all class names, and those will be joined together with a space. And now we can just do it like that. And add our base class right here. And add the grid container, I think I called it. Like that. And we have our styles working again. Okay, perfect. So now I have a baseline where I can add new classes without having to define all new and always have to retype the base scope of our components. Perfect. So now I have this virtualized grid. And now I want this virtualized grid to be able to automatically calculate the size of its parent. But I don't want to do it inside of this virtualized grid, because here I just want to leave the width and height for now. But I want to be able to wrap this with some kind of auto sizer or something like that, so that I can get the correct height in my application. Measure. Measure done. We will be using the use prefix. There we will just be using an accessor. So in Solid, whenever you want an argument to be able to change, you have to make this specific by turning this argument into an accessor. An accessor is just a function returning this type. So let's say users are able to pass in an element right here. This is an HTML element. So right now, this is only one element that will directly be passed in our function, and this function will be called once during the setup of our components. So we have this one element, and we are not really able to react to changes of that element. So what we are going to do is we are going to turn that element into an accessor of an element and import the correct function from Solid. And now it's just, let's take a look at the accessor types. It's just a function returning this type. This way we can make it in a way that it's reactive, so our component reacts to the size of the element changing. So we can do that inside of an effect. So we are calling the element function, and now our effect has a clear dependency on the current element. So whenever this accessor changes, when it's a SolidJS signal, then our effect will be rerun. And the old one, of course, cleaned up. So now we can just use the resize observer, because we want to react to changes of this element. New resize observer. So these are resize observer entries. So this is a resize observer entry, perfect. And now we have direct access to the border box, content rect, and stuff like that. And we are going to use the border box, I think. Yeah, because if someone provides... No, I think we're going to use the content box. This is better. Yeah, the content rect, we're going to use that. And this gives us the width and the height of our element, of the content of the element. So when this element itself has a padding, has a border or something like that, then I guess this should be removed already so that the grid can neatly fit within this element. So now we have this. Let's take a look at the content rect, and I think we are going to start with width and height. I don't think we need anything else, so we're putting that into a signal. dimensions, set dimensions, create signal, like that. And we are going to initialize that with 0, I think. Left 0, width 0, height 0. The nice thing is that these imports are getting added automatically, but if I remove them or fix them, they're getting removed as well automatically, so I don't really have to worry about that, about importing Node internal modules in my browser bundle. Now this is an interesting name clash, that Node.js itself has a crypto module, which has absolutely not much to do with Web3 or cryptocurrencies or stuff like that. I guess this could confuse some newcomers that are diving right into crypto stuff. So our component now returns an accessor of width and height, so that others can just subscribe, so to say, to these new values. And now we are just setting the dimensions. Content rect, width, height. Like that, and now we need observer.observe element, and on cleanup observer.unobserve. Let's leave it as that for now. So now we turn the dimensions, and now we have a custom hook that measures the size of an element that we can then use inside of our component. So let's try that. Const container dimensions is equal to we get our container dimensions right here. Now we add the ref here, like that. And now we can just try out by logging the container dimensions. So this is not changing anything. Interesting, it adds the scroll bar. So the width is reduced because here the scroll bar is added. This means the width is changed and our function is called. And when I resize that, then we get many calls because the resize observer is called quite often. It's really interesting. I noticed that on my new MacBook that the resizing of elements is quite slow when the DevTools are open. I'm not quite sure what's going on there. So this is really not the application. It's just that the resizing itself is quite slow. So now we can use these container dimensions. Width and container dimensions with height. Oh no, oh no, oh no, oh no. Okay, I think I build a loop somewhere, because by adding this element, I'm somehow increasing the size of our element. This is interesting. Why is that happening? I'm rendering let's say I'm rendering with size 10. Now I get an element with size 29. Because I guess because of the text itself. And maybe the semicolons that I added somewhere. Where is it? Here. Yeah, now we have height 10. Now it's better. So let's just revert that. Container dimensions width. Container dimensions height. Yeah, now it's working perfectly. So let's check it out. Inspect. Is it working? No, it's not working. Height 2. Because our div itself is empty right now. So now we can use styles. Height 300. Width 500 pixels. And now we have, and now our grid directly takes the size from this element. So now we can use basically any styles we want to make this div to be the right dimensions, so that the virtualized grid itself will always fill this element itself. Now I'm thinking maybe I should add a wrapper so that you can just add a component right here, like an auto sizer or something like that, so that you don't have to use this custom hook for yourself, and can just render one component right here to handle the sizing stuff here in between. So that's something like that. I think we are going to do that. And then auto sizer, export function, auto sizer. This returns a div. I think this should return the content, and as a sibling, a div that is just used to access the tree to measure the element itself. And this div itself will just be size 0, so that it's not taken into account for rendering. This might be a good idea. So we have this children prop that will be used to render content, where we want to get the is that a new type? Dimensions.ts. Now we can use that. Oh no, here we don't use types, but here dimensions is an accessor of dimensions, and we are returning a JSX element. And now we can return a fragment. We can call the dimensions right here. And we use that one to measure. So the div is HTML div element. So we get access to the div. So you have to use the function form of the ref right here. So now that we can say set div, so whenever this div is rendered or unmounted, then it is set in here. Then we can get the parent. Ooh, I'm not quite sure if this will work. Let's try it like that. Let's say we have a parent. And let's see if this is going to work. Parent element or null or undefined, yeah, this is fine. Let's leave that for now, and now we can render the auto sizer in here. Like that. Yeah, now we get null. Because this element is set up before the parent is set up, so we need to do this in an effect. So we are reading the div, so whenever the div changes, then and now we can do it like that, parent, set parent. And now we can just say set parent element dot parent element like that. And now we have our parent. And now we get undefined on the first render, of course, because the element still, this thing has no parent, only when the application is mounted. And then we have this parent element. Okay, good. Now we can add the element dimensions. And we have to make this type a bit more open. Undefined null, because maybe it's not rendered yet. Like that. And now we can pass in these dimensions inside of our props.children. And pass in our dimensions. Okay. Not too bad. And now let's move that one from here to here and use the dimensions like that. Okay, now let's remove that one. And now we only have our stuff in here. Now we can remove that, because we are just using the auto sizer itself. Perfect. Now, there's one subtle bug in here, I think, because right now this function is called in a tracking context. So whenever something changes that we're accessing right here, this function is going to be called again, which means the virtualized grid is recreated. To validate if this is true, let's just add grid recreated. Here. I got my brackets all mixed up. This one, this one, this one, this one, like that. Grid recreated. Okay, so resizing does not recreate the... Okay, it cannot recreate the grid because it's just a fixed dimension. So maybe we let the width be dynamic. So this one is still not triggering a re-render. This is fine because this itself is an untracked context, but right here, now it should lead to a re-render of our application. Yeah, here we can see every time we re-render, our grid is recreated. So we need this one to be called in an untracked context. And now I have to consult the solid documentation because this is something that I have not done yet. But I know that there's an untrack here, an untrack hook. Okay, so here we can untrack something. So let's just do it like that. Like that. But now we should no longer get any re-renders. Because this is now completely untracked. Create effect. No, it's working. This is cool. That was easier than expected. Yeah, there was a part in the tutorial that handled this untracked business. Yeah, untrack. Can write still notify the observer. This is important. And I think it's safe to just add a new effect in here to create a new tracking context. So I think this should be fine. Okay, so now let's add some CSS so that our container is the full height of our screen, so that we can debug better. Maybe let's do it like that. Let's add a heading here. Solid data grid, and let's turn that into a flexbox. Like that. So now we say style 100% display flag. So I'm just writing inline styles right here because it's just our demo application for our grid. So it really doesn't matter. And it's just quicker and easier to see that when everything is right directly in here. Flex direction column and overflow hidden. This one should not resize, but this one should resize. Now we need some more height 100%, HTML, body, root. Let's see, this is not working. HTML. Like that. And now we have our grid all the way from the top to the bottom of our page. And when we change the size of our page, then it's still going right to the bottom. Is that correct? Let's see. That one is 438, and that one is 38 as well. Okay, perfect. But now, why is our border not visible? Because we are still in box sizing border box mode. Okay, I think we should floor that. Okay, that's better. There's still sometimes this overlap at the bottom. .436 pixels, and this one is 436 pixels exactly. A border of 1 pixel, that's fine. This is weird why the browser cuts off the border at the bottom. Not really quite sure what's happening there. But okay, never mind. This is working as I'd like it to. So now we can just add the auto sizer itself around the virtualized grid. And maybe let's do that not with children, but like that. Like that. Should still be working the same way. Yeah, perfect. Wait a minute. When I change this in size, I have 349 height. This is exactly the space that I have available. Okay. No, it isn't. It's not getting smaller. Why is it not getting smaller? Because that one needs overflow hidden as well. Yeah, now it should be working. Yeah, perfect. And now the border is visible always as well. So that one was missing. Okay, so now we have our auto sizer component that we can use to measure the size of this element to display our grid within. This is kinda nice. Now I think I will do just a very short break to get a bit more tea. And then I'll be back in something like 2 minutes. And then we will get started with the virtualized grid itself. So right now we are only building some scaffolding stuff so that we have a grid to display. And then we will, I think, build some dummy data that we can display in our grid. Maybe let's add some to-dos so that we don't forget it in a second. Generate dummy data. Then we are going to pass some kind of a render prop like this to the virtualized grid. That will be rendered with some context values, some indices, some base styles and stuff like that. And then we can get started with the virtualization itself. So we have to attach some scroll listeners. We have to make sure how we can, so we start with the scrolling itself. And then we are going to start adding fixed elements, so pin left, pin right elements at the top, and maybe even at the bottom, so that you can have those fixed areas within the grid while still maintaining the virtualization of the columns, for example. But that sounds nice so far. And the rendering of cells. Okay, then we are doing a short break and we'll continue in 4 minutes at 3:05. Okay, let's get back into this. So what have we done so far? We have developed this kind of auto sizer component that you can add to your elements that will just measure the size of this element and adjust the grid according to the correct size. I have just recognized that right now we are forcing the users of our component to add this overflow hidden right here so that the element can get smaller. This is something where I'm not really sure how we are going to fix this. We can add a to-do for that later. Right now, our auto sizer forces users to provide overflow hidden to its parent element, because otherwise shrinking of the element will not work. Maybe if we just think about how we could fix that, so that this is something that I'd like to do when leaving these kinds of comments, to leave an option where you can go ahead when you want to fix this to do. So we kind of need to check if our container let's check how the auto sizer in React window is doing this. Do they have an auto sizer? Here, React Virtualized auto sizer package. Let's check that one. So they're getting their parent node. They're adding the on resize. What is that? So Brian is here getting the padding from the palette element. He's getting the offset height. And this is it. So what are those styles? It's only width and height. It's getting the offset width and the offset height. Let's check when we remove the overflow hidden right here. Then we make this thing smaller. So now our element is too large because we only have 196 pixels of room, but the element is 200 pixels high. So the offset height, stores global variable, is 200 because I'm setting the height there. Maybe this is a case because we are in a flex box. Maybe this is a case where it's also not working with the React Autosizer. So maybe we will just leave that for now. Check if React Autosizer has the same flaw. And then maybe we will just leave it at that for the moment so that we can go ahead with rendering stuff. Okay, so first we want to generate dummy data. Now we have to take a look. There was this package called Faker.js. Which was quite good, but it had some issues lately with the maintainer pulling the code and replacing it with some other code, and it was a bit iffy. Or did he do it only with another package? No, the problem was with Faker.js. Faker.js. Here, exactly. No. Also, tree-shakeable and fully typed. This sounds good. Random email, random full name. Ooh, interesting, with a seed as well. Random abbreviation, account, alpha code. Oh, perfect. Random baseball team is cool. Random cat. I think this is perfect data that we can use to generate our stuff, because there's stuff that can be grouped by, stuff that can be sorted, numeric stuff. So maybe let's just use that. Thanks for the tip. Yarn add. Oh, this is also only a dev dependency. Okay, so far our only dependency is SolidJS. This has to be moved to, I don't know, a peer dependency or dev dependency. We'll have to take a look at that for publishing. But now to generate random data. Add a new folder, mock data, mock persons. Okay, so now let's import the whole package. Import star as also from init also. Let's say users can supply a number of elements. And now let's just say so we'll just be creating a new array filled with zeros, and then we are going to map those zeros to random persons. Ooh, this is cool. First name, last name, full name. name options. What can we supply there? Name options with accents. Interesting. Okay. Okay, so we're generating a full name, date of birth, a past date, future date, recent date. This is cool. The autocomplete for the options is not working too good. Length 10. What is length 10? There the length is. Interesting that it's not because it's a generic. Oh god, it's a generic, so we can supply anything to it. Can we just it's only supplied within this file, it's not exported. I'd like to have a function to create a date between some other dates. Yeah, random between date. Perfect. And there we can say new date between 1980, okay, let's do 1950, to new date. Let's just say until today. Okay, now we have a date of birth. What's your problem? Like that. Now maybe let's do favorite team, favorite basketball team, and let's add a country. Oh no, random alpha is country code. That's what I want. So now let's just try that out. Let's load 100 mock persons. Manfred. Beautiful, beautiful, beautiful. So the dates seem to work. Brooklyn Nets, that's looking good. Country. Not even sure what NR is. Nigeria. Now, interesting. Interesting. We get the full country name. A bit easier to parse, I think. Also not country code, but country, I guess. Yeah, country Albania. Perfect. And now maybe let's add a seed. Perfect. Okay, and now let's try something. Let's just do console.time generating mock data. Generating mock data. Done. So now here we can see we are taking not even 1 millisecond for one entry, for 100 entries. Let's do 100,000 entries. And now we are already at 150 milliseconds. And this is already larger than the frame budget that we have. Maybe let's carefully add more data. Yeah, now we are at 1 second. So we are blocking the browser for 1 second. Let's try again. I can already see that it's quite sluggish. I cannot select anything up here in the text because the browser is just locked for those 5 seconds. And for that, I want a mechanism that I can use to generate this data incrementally. Incremental calc. Let's just call it calculate async. And we want to do that by changing our function from being a synchronous function to being an async generator. Because right now I want to add a couple of breaks in here so that I can say, okay, now would be a good time to check if I still have time in my frame budget or if I can continue calculating stuff. And when I have still time left, then I can calculate some more. And only when I don't have enough time remaining, then I want to finish this stuff up. So I want to be able to pause this function from within. The only two options to pause a function are to call await. The problem with await is it always introduces this one event loop tick where we wait for the browser, even if we still would have time for our calculations. The other option is to use the yield statement. So we want to do something like that. Function star build persons. Let's take our person type and put it in a list. Like that. So we have a list of persons. And now we want to do a loop, and in between all of our loop steps, we want to add a yield statement to tell the browser, or to tell the runtime, let's say, to tell the runtime that I want to check if I still have time for my calculations. So now we are going to do this in chunks. So let's say for I equals 0, I smaller than n, I plus plus. So we are building a simple for loop. Maybe we are going to build chunks. Let's say we'll want to build steps of 100 elements at a time. So this is our chunk count. For that chunk index 0, chunk index smaller than chunk count. Then we are incrementing the chunk index. Then we are doing the calculation once. So let's say we want to generate a person. No, we want to iterate over the chunk size 100. And now we are saying let I is 0, I smaller than chunk size I++. Like that. And we want to take the smaller value of chunk size and oops. So this could be something that we might want to write a test for. Like that. Let's just consume this generator for the moment. Okay, this is not working. You know, incrementing the. Oh, okay, this might be working. No, it's not working. So we have a chunk index of 0. Let's just check our chunks for now. We have 100 chunk size of 100. We need 2 chunks because we want to model 101 elements. That's good. So, okay, we have a size of chunk is always 1. That's not good. So we want to take the smaller value. We need to check if only for the last chunk we have to take this remainder stuff. So the size of this chunk is that, like that. Okay, this is better. Only the calculation for the last chunk is not correct. Chunks is 100, 100. Modulo, no, 101, modulo 100, yes, 1. So in the last chunk we should get size of 1, but we are not getting that. Oh, this is not correct. Oh, this has to be like that. Now we get a better chunk size. Now we get first chunk 100 elements and then only one element. Yeah, perfect. That looks better. And now we can log this to console and should get the numbers from 0 to 100. Perfect. Okay, and now we generate, we don't really need that one now. Now we generate data, array.push. Let's add a function to generate a random person. Then we can use this to infer our type. Now we have a person type right here. We are able to generate single persons. Now we're generating single persons, pushing them in our list. And when we handled one chunk, so 100 elements, then we yield. So we are telling the runtime, okay, check for now, please. Let's do it. No, exactly. When we have when we are done with one chunk of elements, so 100 persons generated, then we are yielding to the environment and telling the environment, wait, please check if I still have time to do yet another round. And if not, then I will just continue with the next loop. And in the end, we will just return the array. Perfect. Okay, so now I have to write a function that can consume these generators. So we have a generator function that yields nothing. There's not a single, so I'm always yielding nothing in right here. And I'm returning a list of our persons from our generator. So a generator is made to incrementally create data. It's just like a list, but only lazy, because we can ask the generator or the iterator for the next element of the list. And only then will this element be created. So as long as no one calls yield, we will never run anything in this function. And now I'm misusing this pattern to yield the next chunk of data as long as I have time remaining. Consume async. In here we pass in let's just check. X is build persons. Like that. Yeah, we have a generator. Where only the second parameter is relevant. No, let's do it otherwise. T result. Unknown, T result, unknown. And this should return a promise of T result. Now, so we have our generator function. Where we can call next until we are ready. So let's do it like that. Let now is performance.now. Let's start with a while loop. We will fix that later, of course. Next is generator.next. If next.done, return next.value. Let's do like that. Yeah, perfect. Let's first do it in a synchronous way just to consume everything. So when we are done, then we are just breaking the loop and returning the next value. Otherwise, we check if we still have time remaining. So if that is larger than, smaller than 16, then we can do yet another round. While and is small, so while we are still below the budget, then we can run another round, run another round, run another round. And only when we are above this budget, what do we want to do then? Then we want, we have to yield to the event loop. So we are saying, wait for idle. Promise void, return new promise. And here we're using an API request idle callback. And when this allows us to create a function that will be called when the browser is idle. And only when the browser is idle, then we're going to resolve the promise. What are the options here? Timeout, okay, that doesn't matter. Then we're resolving the promise. So now export async function. Now we can say, let's do it in here. If end minus start, let's say larger than 10 milliseconds, then we are going to await browser idle, and then we are going to reset the start of the next frame. So only when we are almost at the budget, then we are waiting for the browser. And then we're resetting the time. And if we are already done, we're doing it like here. Then we are, of course, directly stopping everything, returning the next value. And when we are not done, then we are checking, do we have time left? And if not, then we get the next value. And do this until our iterator is done. So now, I think we can say return consume async, build persons. Let's build 100, let's build n persons. Like that. And now we have a function that should return a promise of persons. Maybe let's add an async right here to make it a bit more clear. And now let's edit the data. Okay, so we are yielding. This is working. We are still not freezing, but nothing's happening. Am I done? No, I'm not done. Okay, generating 5 persons works. Fast enough. Let's do 50. Works fast enough as well. Let's do 100. It's also done, but I'm not getting a result back. Empty array. Why am I getting back an empty array? Not quite sure if this is working, if the next.done really gives us the return value of the generator. So this is at the moment my best guess that this is incorrect. No, it's just an empty array. What? Why is this not working? So I'm creating a new array. I'm running through this list. Let's add a debugger here. So our n is 100. We have one chunk because we want to create exactly 100 elements. So we are going over the first chunk. This chunk is size 0. Oh, that was the bug. Okay, so that was also still quick enough. That was also quick enough. Let's generate 10,000 elements. That was close. Did it yield? Do I still have this yielding console log? Yeah, I have. Ah, we are yielding already once. Perfect. Yeah, there's one yield in between. So now, wait, I have a, where is it? I have a bookmark. Where is it? That can display lag radar, that one. No. How can I access my bookmarks here? Code lag radar. Is that still working? Yeah, it is. Perfect. So I have my lag radar right here. And when we build a small function, do I still have my small stuff? No, I don't. But now let's just call our build persons. Object.assign window build persons. Let's generate 100,000 persons. And there are 100,000 persons. Let's add a timer. So it took 1.7 seconds to generate these 1 million entries, but as you can see, our lag radar didn't stutter once because we are always yielding to the browser, so the browser can paint the next version of the of our lag radar. Let's remove this console log right here. Now 1.7 seconds. So now we are at 10 million. Let's see what's happening. So it's, of course, it's a slow process because we are generating 10 million random persons. The UI is still responsive, and after 18 seconds, we are done. Perfect, cool. So now I can create these functions that at any point in time just have a yield in them to let the environment run for a bit, so that we can write long-running functions that don't block the main loop and still control if they should be running synchronously or not. So we could still write a comparable function consume sync, just for cases where we maybe just want, for testing purposes, we directly want to get to the last result of our generator. Then we can just do that next is generator.next. As long as we are not done, let's call next as generator.next and return next.value. So maybe let's just try that. Maybe let's take 100,000 where we have 204 milliseconds. And now let's replace that with consume sync. There, maybe you saw that the radar has this small chunk where the calculation happens. We can maybe increase the size even more to block the event loop even more. And there you can see we have this large red area. Oh, okay. This definitely removes the lag radar. Code lag radar. So with the sync variant, we can see that the browser is really frozen for a couple of seconds. Sorry, just have to answer a colleague of mine. So now we can generate mock data without blocking the event loop. Cool. So now let's add that to our application. And we are going to use the create resource function from Solid. And we want to generate 10,000 mock persons. Great. So this is just something like React query. So you pass in an async function, and Solid will make sure that will give you a correct return value where you can interact with the data to display it at a later point in time. So, for example, this returns two things. Let's just check. It returns a resource and the resource actions. Perfect. Of course, this is a signal. So first we get undefined, and then we get our 10,000 persons. Okay, now we have dummy data. Took us only so long. But we have dummy data that cannot block the event loop. So I can add in even more persons, and we have to wait a bit more, of course. But the application is still responsive, so I can still interact with the app. Let's check that again with the lag radar, just to see if Solid adds some kind of overhead when using this resource. Code lag radar. Yeah, we could see a small little pause right here where Solid is parsing the response and turning the response into a signal, I guess. So we have 1 million elements. Maybe let's try the 10 million again. So now we're generating the data. And then when it's done, we expect a small little hiccup in the diagram, in the lag radar. Oh yeah, that was a very large chunk here, where Solid parsed the 10 million elements and converted them into a signal so that we can subscribe to each and every one of those. So I think we could try that. No, I don't think so. Okay. So now we have our persons. Maybe let's reduce that to 10,000. Maybe let's take 1,000 for now, so that we can try out. So let's get into the virtualized grid. I personally don't like to pass in the whole list of persons down there because I just want to work with row numbers and column numbers. So what I'd like to do is I want the rows like that, so that we can say let's add the person count right here. And add columns, maybe for the name and the date of birth for now. And then I want to render the cell. And want to be able to do something like that. Props. And want to render the cell something like that. And then the grid can then figure out which cells are currently visible. Maybe we need a get row height function, get column width function, like that. And then the virtualized grid can then calculate which cells are currently visible, so that these cells will be rendered at the moment. So by doing that, we can pass in an arbitrary cell renderer that renders divs. It could render SVGs, for example. and then we can later layer on top our data grid. So our data grid will be using the virtualized grid below itself. But this is our interface for now that will just handle the virtualization of elements. Later we will be adding something like, I'm not quite sure, pin left count, pin right count, and stuff like that. But I'm not too sure how we are going to do that so far. Maybe we will think about another API. So of course, calculator, I think we should move that. Oops, we need that as well. Export function consume async and consume sync. Let's call that file consume and add the imports here. We could also just yield in every loop, then we could omit this chunking part, which would make it a bit easier on the eyes. But I think this really doesn't matter at the moment, because this is it's a dummy function to generate data. It doesn't really matter how complex or how easy it is. Maybe when we are using this incremental logic, these generators for real world stuff, then maybe we will be adding more options and more APIs to make this easier, make it easier to build these functions. So maybe let's now start with the virtualized grid. Let's increment the size of our screen a bit, because this will become quite large. Yeah, as you can see, when I reset the browser, macOS just totally loses it. But I really like my lag radar, so that we can see when we introduce some problems to our application. Okay, virtualized grid props. Now we want our row count and column count. Let's call that row count. I think that's better. Number, column count, number. And we definitely need functions. We need a function to render the cell. Not quite sure if Solid has a component type. Let's see. Yeah, just a function that returns a JSX element. That's perfect. Nice grid cell props. And there we will be able to pass in the props for a cell. The cell will get a row index, a column index, and a style. Not the correct prop. So every time I don't really know the type of a prop, we just hover over the JSX, then we can see it's a JSX.css properties object. So we are just gonna import that directly. Oops, sorry. No, I can't. Then we're using the JSX.css property. So now we have the basic props for our grid renderer. Let's say the row count is equal to person count. Column count is 2. And now we just spread props.style right here. And we render props dot row index, props dot column index. Yeah, I think that's enough for now. So now we can render all the cells in our grid. And then in here we can, for now, just iterate over all cells. Okay, we need function to create lists. Maybe we should, no, rows, columns. So I'm thinking right now, if I really want to pass in cell count and row count, because this might lead to unnecessary creation of DOM elements. Because in Solid, whenever you don't have a VDOM in SolidJS. So Solid does not get multiple versions of a virtual DOM and do a diffing algorithm to check which DOM elements need to be updated. But in Solid, every component is a constructor function. Let me just fix that. It annoys me a bit. Every component is a constructor function that's run only once and that creates real DOM elements. So whenever we run this cell function, we are creating an HTML div element that is bound to those contents. So whenever those elements change, when those are signals, they will automatically change in the real DOM element without having to run the whole component again. This means, no, it's not really a problem. No, it's not a problem. This means that the column and the row index are the key for the rendering in our case. Do we want that? So that means whenever I reorder columns, I'm not moving the columns, but changing the contents of the columns. It's not really what I want. Maybe we should have some kind of a mapping step in between. Maybe we won't do it like that. Maybe we are going to do it like that. Rows. T row. T column. So we have any arbitrary object, rows, T-row array, columns, T-column array, and of course in rows and columns we can then add those two. And make these ones accessors, because when we reorder the columns or rows, we don't want to recreate elements, but we want to move the elements. Like that. So now we have the cells. I think we can make that one generic. T-row, T-column. T-row, T-column, like that. And now we can simply loop. Props dot, let's first loop over the rows. row index. There we are going to loop in each of these rows. We are going to loop over props.columns. Column index. And now we are going to do props.cell. Column index, row index, row column, row style. What's your problem? The expected type comes from property column, which is declared. This is the row, this is the column, and this is matching that one, the row, the column, like that. So now I can say rows persons or an empty list when the persons are not yet loaded. No, this already contains the data. Where is your problem? Unknown array. Let's for now add just empty objects like that. So that we can render our stuff. And now, where's the problem with that? Oh, this is an accessor. Much better. Cool. So now we have our cells right here. And of course, we have to fix the width and the layout of those elements. But I think we should have all of our cells in the UI. Yeah, there are all of our cells. Of course, these are way too many right now. Yeah, exactly 2000 to 2000 DOM nodes did we render right now because we're simply rendering all of them. Yeah, but of course we are going to change that by virtualizing them. Now maybe let's add some styles to the grid container. Okay. This is not too bad. Now I'm not quite sure how I want to provide the column width. I could, or the row heights. I could add the height and width directly in here, in those objects. Or I could have callback functions right here. I think we are going to use the callback function approach. Because then we can do it on demand. Yeah, right. Okay, because right now the rows are eager. You have to create all rows before rendering. Exactly the same with all columns. And when we do it as callbacks, the callbacks can only be called. We can build it so that the callbacks are only called at render time. So we're only calling it for the elements that are visible. So let's add the props for the column width and row height. Oops. Like that. Go on. Let's add more props. Get column width is a function that's called with column. And it should be return a number. And get row height, row t row. It should also return a number. Okay, and now we have this calculation for scrolling because, okay, so we need some kind of a signal that gives us the scroll position. Oh, but to determine the scroll position, we have to map all elements to their height and then sum those values up. So we have to do it like that. Oh, I think there's a function in Solid. Okay, so right now we are again mapping over the values, so we are still in this mode of doing it on demand, but we need to, because to get the total height, the height of the scroll indicator, we need to go over all elements once to determine the height of the elements. Oh, I don't really like that. Map array is a quite expensive operation. Let's check the source code for that. Let's jump into the GitHub editor to find our way around more quickly. Packages, solid, source, reactive array, map array. Yeah. So the cool thing about map array is it does a bunch of work only once to set up the array, and then has a connection between inputs and outputs. So whenever one input element changes, map array determines if our mapping function should be called again for the input or output, or if it's still the same element. This is very important because for when we are mapping over a list of objects, we don't want to recreate all those DOM elements for every element. So Solid can figure out if we are still working on the same row, if we're still working on the same column, and then it will just do nothing because this function is already called for the same object and the same row and the same column. So it's simply not doing anything. When we are doing this with the row heights and column widths, we could create a list of numbers that directly map to the correct columns and rows. So when these change for a row, whatever the reason may be, then the size can directly change in the DOM without anything else having to occur, because only the used locations can be adjusted. I think we are not going to use map array for that, but we are using whenever the let's see. So they iterate over the list, create the root, create a bunch of new elements. Yeah, and then they're creating a map. So we have a map where there's a row in every, where there's a map that contains every row. So this can become quite large, just to be able to reuse the column widths and column heights. The alternative would be that every time anything changes within a row or a column, that we recalculate the complete width and height of the grid. So we reiterate over the complete list and create the numbers for the columns and rows. I think this is not bad, because right now, whenever the something changes in the width or the height, we have to go through the list to compare the elements directly again, which is definitely more expensive than just generating new numbers. So we are going to do it like that. Column width is a create memo. So we are iterating through all columns and mapping them. Where props get column width, column. The same thing will be done like that. And now we have a signal with all column widths and all row heights that will be recreated. Let me check that. Wait, where are elements added to this list? Create elements mapper. So for every element, a root is created. And then every element is called with a new root. Yeah, it's great here in a totally new copy. Yeah, we have new indices. Yeah, iterate through all elements. Then they're moved around when they move. Yeah, that means when a new element is added, a whole bunch of stuff is going to happen. I think it's the right call to just calculate the height directly. So what we can do now is we can use styles right here and do position absolute. Let's make the grid itself position relative so that absolute positioning is working. Is there not a shortcut for that? Let's use that one. So we absolutely position these elements. And now we need to access the previous elements so that we can have, wait, like that. And so let's iterate over that again. Like here, no, here. Map width. Index width. So we are going to mutate elements. So maybe we are going to do it like that. Now we're back to elements. Whoops. Okay. Like that. Oh, I don't want that. No, these two. Like that. Yeah, that's the correct indentation. Okay, so here. Let's do it like that. So we have objects with width, with the correct width, and a left value. And now we will probably calculate the left value. And this is the previous element is columns index -1. Or left 0, width 0. And now we can add the left of this column to be previous.left plus previous.width. So now we are iterating over all columns, return column, return objects for each column. So we have column widths that each have a width and a left property. That's good, okay? So the same thing we're going to do for the height. Okay, row height. Maybe we are going to try that out with the map array variant later. Top and height. Rows. Top height And now we can we are recalling props.cell. Whenever something about the row change. Okay, maybe I think we will need to move that somewhere else at a later point in time. But let's see. So we have a left. So that means this function has a dependency on the column widths, which means that whenever the column width changes, this column is recalled. I think we will need a console log right here to make sure that our cells are not calculated too often. Because that is definitely something that we need to avoid to rebuild all those cell elements, because that would mean that we would rebuild the HTML elements as well, which is definitely not something that we want to do. So column index, whenever we reorder, this should work. Let's do it like that. And do the same thing for rows. With row dimensions, and now we can do left is column dimension, any, number, what's going on? No, that's okay. This is interesting. The broken syntax confuses him, so the autocomplete is not working. But when I have an autocomplete, Typescript knows that this is, of course, false. Top, row, and height. Get column width is not a function. Okay, yeah, perfect. 200, get row height 30. Okay, let's see. Oops. Style equals to props.style. Oh, that's looking better. Much better. Cool. So now we have all of our elements that are currently visible. Oh no, those are all existing elements. And now maybe let's try changing the column width. function toggle column width. It's just switching between 200 and 300. Get column width is using that one. And now we can say on every cell we just want to toggle the column width. And nothing is happening. Why not? So our function is called. So that one is working. So our signal is changed. So this function is not reacting to signals changing. Where is the use get column width? Is inside of a create memo. Why is that not working? So that means when we are calling this memo, the column width signal should be triggered. Why is that not working now? Maybe it is working. It is working. Okay, so that one is working. So we have new column dimensions right here. Oops. That means, here, that place is not tracked. Perfect. Because inside of the loop, we are not in a tracked location. So these functions are not causing any effects. That means, oops, what did I do here? That means we need to make that one an accessor. Now the reactivity can flow. And now I have broken it. Perfect. Why? Because I'm not calling that one like that. Like, wait a second. No, okay. So that one is an accessor of styles. Okay, that's good. Perfect. And the cells are not being rebuilt. Cool. So now I can adjust the width of a column without the cells being rebuilt. The only calculation that's happening is that one. That calculation has to be redone because I have to check every cell for the width to have it ready. And then this one can be used to pass in the style. Since that won't be recalculated, since that is not, that's not doing anything, it's just defining a function. So the signal read is deferred until someone reads the function. Right here again, signal is just a function is created that's not reading from any signal. And that means in here, inside of the JSX, here we are reading the signal. So we are reading that one. That means we are reading the column dimensions. That means we are reading the column dimensions. That means we are reading the get column width. And that means we are reading our column width signal. That means when the column width signal changes, all that changes is the styles of the element. So that is working. Perfect. Okay, so now we can adjust the column width. Oh, let's remove that. And very important, no cells being rebuilt. That's very important for me. Okay. Now, what are we going to do next? I think we can start with the virtualization. So now we need a signal to get the current scroll positions. Maybe we are going to increase the column width a bit to have something like 500 and 600, like that. So now we can scroll. Perfect. And now I need a signal for the scroll position. I think this is definitely something again. Use scroll position. So we could use the HTML on scroll for that. Yeah, I think we're going to do that. Yeah, I think we're going to do that. Let's remove that again. Yeah, scroll left, set scroll left, use create signal 0 on scroll top, set scroll top. So to be able to calculate which cells are currently visible, we need to be able to have the current scroll position and the dimensions of the window. We already have the dimensions from our props. So now we only need the scroll position. Let's batch those two updates together. So we are just saying and scroll left. Here we are setting scroll top, and now we have a signal for the current scroll position. Let's display that somewhere. Here we have our whoops, like that. For the scroll top, and there now we can see that when we are scrolling, those values are get updated immediately. Okay, that's good so far. And now we can calculate which elements are visible. And for that, we need the column dimensions, the row dimensions, scroll top and scroll left. Visible cells, I think. No, visible rows. And const visible. columns. I have a feeling that we can definitely reuse some logic because it's basically the same thing. So maybe it could be useful to move that into a unified interface so that we can make use of that. But before we are going to do that, I think I need a very quick break, another one. So I think we will continue at something like 16:45. And there we'll do a short recap what we have done so far and what the next steps are and what we want to achieve today. And see you in a minute. Okay, let's get back to this. So what have we done so far? So far we have built a dummy app component. We have generated some dummy data. For this dummy data, we wanted to build a process where we can generate the data incrementally while giving the opportunity to just use a yield keyword to say, okay, now I want the environment to work a bit more so that the event loop doesn't freeze or doesn't block. And we are building a generator like that where we can place in yield in strategic placements so that we have a bit of work to do. And then we say, okay, now we want to check if we still have time left in the current frame, in the current animation frame, or if we can add one more element. Dun, 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 dun. Okay, so this is where we can then use consume async to just consume this generator and get the result in the end while not blocking the event loop. We noticed that we can then call this function with 10,000, 100,000, 10 million. I think 10 million was the highest I tried to generate data for. And it just went without any problems. So that we now have a way of generating data, lots of data. Then we started with our virtualized grid. First, we wanted to have the dimensions in our component. So we built this auto-sizer component that we can just insert somewhere in our markup. And this element will just take the full size of its parent element, read it out from the DOM, and pass in these dimensions via this dimensions field into our component. So now then we started with the virtualized grid itself. In here we added the props to be able to add rows and columns to our grid that we can then use to iterate over the visible ones. So far we iterate over all rows and all columns, get the current row dimensions, so where does it start, where does it end, and call the render prop from here, where we are in the end rebuilding the cell where we just pass in the style. So we have our cells in the DOM right here all next to each other. So far so good. Now we want to replace these lines with only the visible rows and the visible columns. And I'm not yet sure how I'm going to do this. I think first of all, we are changing this from being direction specific to being a unified interface. So we always have a size and a start. Start, size. Accumulate sizes. And that below. Element dimensions, dimension range maybe. Start number, size number. You have this dimension range right here. That. So we have size, in the start, okay. So now we want to calculate the visible rows. This is definitely something that we can move out of the component itself. And I think we're going to create indices. So we have an item count. We have total size available number, start of visible area, size of visible area, and I think get item size. Okay, so now we have this function. This might be something that might be worth sourcing out, especially if the grid is quite large and we are scrolled all the way to the bottom. This might be something that we'd like to move out of there. But we will see if we want to do that. Okay. Now, let's say items to skip. First visible item index. We go through all items. So we're just looking for the first element. So we're looking at find first. Where const range is get item config get item dimension range I. And the first visible item index is the first one where the let's see if we have a row right here. And now we scroll this row. Can I somehow... So it still should be visible. So it's visible when the bottom of the row is below the distance from the top. Is larger than the distance from the top. So if end is larger than start of visible area, then this is our first visible index. First visible item index is I and break. Okay, then last visible item index. Now we continue going through the elements, getting the range. We only need the start, and we need if start is smaller than the size plus start. Area, and now we can say if range dot start. Oh no, we have to find the last one. Oh, let's just find the first one that is larger. End of visible area. And this is our last visible item index. And now we can just return I need some array helpers. Cons result equal to list number array. Now we can create ranges, and now we say from first visible item index to last visible item index. This one will be excluded by our range function, so we have our visible indices like that. So now we can just say calculate visible indices, get item dimension range, item count is props dot rows dot length. total size is row ranges. Get the last one dot start. The total size available, I'm not even using that, right? Total size available, no, we can remove that, perfect. Even better, even better. Size of visible area is props.height, and start of visible area is scroll top. Now we can just get the row and return that. Okay, now we can just adapt the same thing for visible columns. Now we can just say visible rows and visible columns. Okay, this does not seem to be working so far. It's not too bad. The total size is missing for the scroll container. That's the problem. So we need some background right here. You know what? Maybe we should just add some stuff right here to make it a bit easier. Like that. Like that, and now we can just use the end. This is good. And where did I want to use that? For the total size right here. That. Now let's do the same thing for the row. and height last row dimension punkt end. Okay, this is looking good. Ooh, no, okay, the row index, of course, this is not working anymore. Is that a problem? That is a problem. So we need, what we need to do here is we need the index, we need to maintain the index. Like that. So we maintain the index. Yeah, that's better. Like that, and now I can do it like that. Like that. Oh no, now the columns are getting recreated whenever the dimensions change. Damn it. Okay, we are going to fix that soon. Okay, I think let's do it like that. Let's remove this mapping logic right here. Yeah, that would have been a problem otherwise. So these are just the visible row indices. These are the visible column indices. Is there any? No. Number? Why? Number, right? Okay. It's okay. There possibly some brackets missing or something like that. No, it's looking good. And now I can map over the visible row indices like that. Row index. Column index. Row index. And now I have the column index. That's okay. Number. Oh, this is no longer an accessor. Is that cool? Yeah, that's okay. No, that's not really it. Now I have the problem when I reorder columns that the content is going to get changed because we currently have the index as a key for the column and the rows. Which means if you wanted to have animations for sorting rows, for example, it wouldn't work because the indexes are not changing. So what we need to do is we need to do map array. Okay, we have the visible row indices like that. And now we have to map the rows. So we have to use a slice while maintaining the original index. So I could use a map array to create the objects with the correct indices. Or I'm directly using the map array on the large list of objects. And then I could do the filter inline directly. On the framework that's simply diffing, like React, for example, this would be a bit easier because you don't have to care about the identities. You can just do calculations and in the end diff the resulting rows. But in that's a very full cup. But in Solid we have to be careful to maintain the correct identities. So the source should always be the rows. So I need a lookup map for each row for its current index. I mean, I'm iterating each row anyway, each row and each column. Is there a possibility to use an object as a lookup in the list? Where is the Solid documentation? So there's map array, where the elements are cached by reference. I think we will just use map array for everything. And once we do that, that's a bit of a problem. So let me jump back into the map array function. It reads the list. So on every change we have new items. in here. So this is everything in here inside of this untracked is called. Okay, so yeah, when it's empty, okay, that's boring. When the old list is empty, that's the initial render. And the old list is, I guess it's just initiated to 0. So when the old list is empty, then we map over every item and create a root element for this item. Okay, if the new list is not empty, then we create a new array. Create an array for disposals, create an array for temporary indexes. And then the code is looking until the first change element is found. The same thing goes for the end. So we have in the middle some stuff that changed, and there, for every change in the array, we are creating this new map and this new array so that we iterate over it. I think we should be fine. Let's just try. We will just try it by using these reactive helpers. So now let's do it like that. Let's say we have column descriptors. Here we have a create memo. And we have a map array. Is that correct? So we have to do all our reads here on the outside. Yeah, but we don't have them on the outside. So everything else has to be signals. That's okay. I think that's good. Okay, so what we are doing is we are saying map array props.columns. And we have a mapper. Column index. Like that. Let's do it like that. So maybe let's just check the for render flow for create memo. Yeah, it's exactly the same. It's a create memo with a map array with props each. Okay, perfect. So we have map array. What are we going to do with each element inside of the column? First, we are going to return objects. Here we have the column itself. Then we want the index itself, which is an accessor. Good. So whenever we move the columns, the index will just update in place, and our columns will can maybe even animate in the UI and move around and stuff. Okay. So now we need the sizes. Oh, map array is not. Oh, that's not working. Shit. Is it? What's the result of map array? It returns a function accessor. That's okay. So we could mutate the dimensions in the end. That should be possible, I think. Oh God. Okay, we have the column, we have the index. Let's get the size is props dot get column width and call it with the column. It's good that we don't need the index at the moment. Well, this could be not too bad. So we have size, start, 0, and 0. Now we have our column descriptors. So we could do that as a... Yeah, because that is not tracking. So props that got get column width. We have to do like that. So that the changes land in this object. So these ones need to be... Fuck. Everything turns into a method, which means everything can theoretically animate directly. But the setup, it feels like the setup will be quite expensive, but we will just try it out. Oh God, so we have super long chains in the rows where the placement of a row is dependent on its previous row, on its previous row, on its previous row. So by changing the height of the first row, we have a chain of... Oh God, this is not a good idea. I think we should let... Maybe we should leave that as is. Maybe we will only do like that. Okay, so now we need the same thing for the row descriptors. Let's do that as an array. Like that. Like that. Now we have column dimensions. That's okay. We have row dimensions. That's okay. Now we have visible row indices. But we now want to have visible rows directly. So we have visible row indices. So we are mapping how can we access those in a performant way? So we don't need to have this as indices, but we need to have this as a complex object where we get the index from each element. So we are doing calculate visible items. Item where we have items, item array. get item size. Like that. Also, no, that's just that one. Like that. So the first visible item is if item dot you can just return an empty list. We go through all items. We get the item. No way. So right here we want to use the row descriptors. And recalculate that. So we have a dependency on the elements anyway. So we can read out those values. That should not be a problem. And they should be sorted correctly. Otherwise map array would be a bit weird if it would change the order somehow of the elements. So this is something that I depend on. Okay, so first visible item is that one. I have to schedule a short in-between break. Okay. Yeah, no? Okay, no in-between break. Okay, so let's get back to this. I want to calculate which items are visible. I can retrieve an item, and I can get the dimension for this item. So now I go iterate through all items, retrieve the item. And I can put the item in here. Okay, so last visible. Ew. Yeah, no, I need the index. 0. I. Last visible index. So like that, here we can just put in the item is config.items I. So in here we pass in the item. And we can pass in the index like that, and now we can take the index and return like that. Let's do that imperatively, I think. Okay, so now we return the visible items. So now we get the row. No, we are taking the row descriptors. Row descriptors. Okay, whenever the row descriptors change. Oh. I think we have to do like that. Yeah, I think so. Let's hope for the best. Okay. Oop, visible row in. No. Yeah, visible rows. Get item dimensions as row descriptors. Like that. Like that. Property. Right. There's a function returning a t-row. No, that's not right. Oh no, I have the index. Right? Row dimension. Like that. Okay. Items. Yeah, that looks okay. Oh, I'm excited. And I'm really not sure if this is going to work as I want it to. Column dimensions. Column bar dot index items like that. Calculate visible items like that. No, we don't need the column. Oh yes. No, we don't need them anymore. Ah yes, we wanted them. To directly access those. The same thing will be done here. And now visible column descriptors. Now we should have objects with column and the correct index. Perfect. Visible row descriptors, visible column descriptors. Like that. And the dimension can be pulled from the column dimensions with column descriptor dot index, which is an accessor, yes, and row descriptor dot index. And now so this has to be an accessor. Now row descriptor dot index, column is column descriptor dot column, and row is row descriptor dot row, and we are green. Okay, now moment of truth. It's working. Wait, is it really only rendering the visible rows? Cool. And as soon as I start scrolling, we see that rows are removed down here and added up top. So we only have those few visible rows or column rows. Let's try the scroll bar. Okay, we have a weird spacing issue. We have exactly one item is missing. It should go up to 999. So one item is not visible yet, and the columns are not working. But this is okay because I think we have the last column will always be cut off, the last column and last row. So maybe we are there here. Let's do that. And I think this is it. Great. Really cool. So now maybe let's add some more columns to this to check if this is still working. Perfect. And now let's check the console. We scroll a bit. A new column is visible and 12 elements are rendered. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Why 12? 11. And one more up. No, not one more up top. Maybe let's try that again. So when scrolling down, 3 elements are rendered because right now it seems like each row renders 1 element too far on the right. Let's fix that. I think we can fix that quite easily. No, why is it? Wait, why is this working? Oh no, because we still have, okay, never mind. So in here we are looking for the first element where the start of the item is after the end of the visible area. And this is the last visible index. This should be the last visible index. I think now we have... No, that looks better. So when I scroll, I get exactly, scroll a bit, 2 new elements, because I scrolled down. Those 2 columns get rendered in addition. And now when I scroll to the right, I get 11, because one, two, three, yeah, we have a 3rd column. And I think down there might be, yeah, this one is, there's one more down here because it's already a bit visible. Maybe let's try that again. Let's reload. Now we have exactly 20 elements. Oh no, it's still one down there. Maybe let's decrease the size a bit. Now we have exactly 10. I think here some might be missing. No, this element is just so wide. So can we still toggle the width of the columns? We can. But the main question is if our cells get rebuilt, and they're not getting rebuilt. Ooh, cool. So let's maybe decrease the size of those elements again. Like that. Like that. And now maybe just to try, let's add some CSS animations, CSS transitions. Just to see what's happening. Transition all 0.2 seconds. This is not too shabby. Okay, it's not working on the right because so many elements. And when we are here, we are in column 13. Now we click and now we are only in column 9, so there is nothing to animate. So when the new indices are visible, they are so far off screen that they are directly detached from the DOM, so that the animation is not working in this case. But that's okay. Animation is definitely not a priority for me. Okay, so now we have a simple scroll virtualization solution. Now, what's happening when we refetch the data? Let's add a button. Button refetch data. Person actions refetch. So when the data changes, all cells are replaced and completely rebuilt. That means when we are, is there a problem for the scroll dash? I don't think so. No, it's not. Okay. But that also means, no, the question is what happens when I update one element. Okay, let's check the docs first to see if create resource is using reconcile. Great resource here. You can call mutate to directly update the data. And pass in arguments for refetch. What can I do here? Yeah, nothing. That's just from the generic. They can pass info inside of my fetcher function. That is not helping me. So maybe let's try that. Let's try the following thing here. Instead of calling refetch, let's do it like that. Person action start mutate, new value. Let's generate the same amount of persons. Load mark persons. Perfect. And now we are going to say reconcile. Is it not called reconcile? I think it's called reconcile. So let's try that. Okay, I think this is working. Now maybe let's try to display some some info right here. So we get the column init and the row index right here. So we get the person is persons props dot row index like that. Like that. Now we can do it like that. And now we can render, instead of the row index, we are going to render person.name. Okay, this is not working. Is that to be expected? So my signal is not changing. So this one is not working. Let's reconcile. Are my persons changing? This might be interesting. Yeah, they're definitely changing. The names are changing. Maybe we need to add IDs. Let's do that. Load mocked person. Like that. Real index is chunk index times chunk size plus I. Oops. Like that. So maybe let's add some kind of real columns right now. So let's have a column for ID. And a second column for the name. And now we're just going to do let's use those. Add our columns right here. Like that. Now we have our column, and then we can render our column and person. Okay, we have some type errors, but that's really not our concern right now. Okay, so now we can see all of our persons. That seems to be working so far. Oh, the refetch is working, but it's not updating. Why is that? I'm not quite sure if the mutate function is meant to be used with that reconcile, because theoretically yeah, this is not updating as well. It's reading the new values, so the new values are in here, but for some reason it's not working. So this is working, but now I guess our cells are being recreated. Yeah, all cells are rebuilt. I don't want them to be rebuilt. I want them to change because our IDs are still the same. Let's try using produce just for the sake of it. We have the store stuff. Yeah, it's a setter functions. So theoretically it should work. Yeah, these are only meant to be used with the store. Not quite sure if use resource is meant to be used with is already a store. Create a signal and not. I think that is the problem. Okay, maybe let's move away from create resource then. Oh wait. Could we? Return the state setter function. But it's not triggering the signal because it's a signal and not a store. That's the problem. Our data is currently a signal and not a store. So when using mutate, am I allowed to use? No, because then they are not updated, the elements. Yeah, the problem with SolidJS is that Googling for stuff is basically impossible. SolidJS reconcile create resource. Oh, this is inside of the fetcher we can do this. We can use reconcile. That's interesting. So this one is quite sure if this is the correct type. Okay. So in here maybe we can say, okay, this is all a bit contrived. I just want to have a function that's where a lot of data, where just one part of the data is changing. Okay, let's just rework this to be a store. It doesn't matter for us anyways. Store. store where we have persons, which is a person list. Or null. Like that, and then create effect. Load mock persons dot then. That. And now we will do the refetch right here. That. And now our data is updating without a rebuild of the cells. So we can, in a fine-grained way, update our data, and only the cells update that really use this data and display this data. So this is cool. Okay, I think regarding implementation, this will be it for today, but we have to think about how we are going to do the pinned columns and pinned rows from a CSS standpoint. Because so far I have one grid, one HTML element for the grid itself. This element is relatively positioned. This one, it's positioned relative. And all these cells are directly rendered within the grid. Maybe let's remove this status stuff at the top. Where is it? Here. That. We don't need that anymore. So we have this grid, and in this grid directly are the rendered cells. And we have one element within the grid element that stretches the element to the maximum size, because we're only rendering the items that are currently visible. And this element stretches the container to be the full size so that we have scroll bars. So far so good, but now I want elements that are not scrolling. And there I'm really not sure how we are going to do this, but I will check the implementation of AG Grid just to get an inspiration about how they are doing it. So one possibility would be to have 4 different areas. So one div in the upper left-hand corner for the, or not, it has to be 9 areas, because we have pinned columns on the left and on the right, and we have pinned rows, maybe on the bottom and on the top. So we have 9 different areas that have to synchronize their scroll position in some way or another. Yeah, same way here. So we are scrolling up and down. This is stuck to the top. But when scrolling left to right, then of course this has to move as well. So maybe let's, okay, I guess this could be, yeah, this is the same thing. Where there are just multiple different areas that are just synchronized manually, I guess. Let's get that one. Temp1.scroll left. 0. Now when I scroll this and do this again, I get 0 again. This is interesting. 900 pixels. Because this is not the same thing that scrolls. Yeah, now then we inside of there we have pinned headers, these ones, and we have pinned right headers, and we have exactly. So those are the three elements, I think. So now that one should scroll. Let's check how many. Yeah, here we have the header, the content of the header. So this is the header itself. Temp2. Don't scroll left. Now let's scroll a bit. Ooh, they are not scrolling, they are translating. They're translating these elements as well. No, they're not. Yeah, that would be a bit too expensive, I guess. Yeah, they're also not translating the rows. And we have the body that is scrolling. Something's happening here on scroll. That could be the hover. Yeah, I guess that's the hover effect. Yeah, of course, they update the visible lines. So they just have different areas that are then synchronized. And some of them are scrolled with your translate, and others are... Let's just check that one. Temp3 dot scroll left. Yeah, that one is scrolling. And the rest is then translated, I guess. Let's take a look at column pinning. So right here we have this example of pinned columns. Yeah, perfect. Yeah, and there we can see all the different areas. So we have 1, 2, 3, 4, 5, 6. And if there are rows pinned to the bottom, then we have another area, 7, 8, and 9. And these have to be synchronized. So whenever I scroll that one, let's see. Yeah, so we have a totally different area for those pinned rows. Yeah, pinned left elements. This is the element that's the whole size. So you can see it's 369,000 pixels high. And in here, this is the interesting. So it's only one element that's scrolling. Dim one, let's scroll top. Yeah, 486. 78, sorry. Yeah. So we have those 4 areas, and by synchronizing them, by having just one scroll container, but only that one has the scroll bar, yeah, that's okay. These ones are translated. These are just the columns that are our full height. And this column is scrollable. Wait a minute. Is it possible to implement that one via overflow as well? Yeah, because up here you can't scroll because this is not a scrollable element, only the bottom half is. But what if this one was also the full width? No, that's not working. Because I have this detachment, because here I want those to be fixed. So they are rendering columns. So we have the left column, right column in this stuff. And then I guess up here we have some header stuff up top that is synchronized with the translate. Let's check the row pinning stuff. So same thing. Yeah, we have one column. Okay, and these pinned rows. Where are those? Yeah, they are completely laid above the content. Yeah, it's just like a second header. Then we have the viewport of the body, and there we have the columns for the scrollable stuff. And then below that we have the content itself. So I'd like to see an example where columns and rows are pinned. Can we do that? Let's check the documentation. Column pinning. We can just, on a column, we can just say pinned left. So now when we go to the row pinned example, we can add that in this editor. And now we can just say somewhere, maybe somewhere in the styles, that the athlete is pinned to the left. Okay. Yeah, now we have the scroll bar down there in the column. And we have this fixed thing. So now we have now we have a column for these pinned rows. And for every area we have a separate column. And in these columns we just have the scrollable data. So we have, to summarize, we have in our grid, we have 3 columns for the pinned left columns, the non-pinned columns, and the pinned right columns. And outside of these, and inside of these columns, we just have the full size. and the full width of the scrollable things. So the up top scrolling can just work without any synchronization because it's just one element where all of these are positioned next to each other. And the horizontal scroll only happens in here. So we don't have to synchronize anything there. Except for the pinned stuff up top, where we have to synchronize the header scroll value and the pinned stuff at the bottom and the top, which we have to synchronize, I guess. Let's see. Yeah, these are just moved with translate. So they're not really scrolled, but translated. And I guess possibly they are translated in a request animation frame, I'd guess. 306 pixels wide. 1000 pixels wide. So that one, no. That one might be the one that scrolls. Tab 1 dot scroll left. Perfect. And now the question is, can I edit this? I can. Yeah, perfect. So just by scrolling that one, these at the top will just synchronize it themselves, possibly in a request animation frame loop, so that they always stay the same as this lower thing here. Okay, so I guess this will be tomorrow. This will be our first to do, to add the pinned areas at the top, at the bottom. I'm not quite sure if we could pin multiple levels. I think it should be possible. But there's already quite a lot happening on scroll in my application. So I'm really excited to see how this performs with a large data set, with more complex stuff in here. But so far it is working quite good. Maybe let's take a look at the lag radar once more. Where is it? Code lag radar. Whoops. There. Pushed it off the screen. Let's increase the amount of visible cells. Wait, let me add more columns. With it, or application columns. So now we want to render the favorite team. And maybe the date of birth, the country first. And then the favorite team. Oh no, and now the date of birth. Let's try that. Now maybe let's repeat those columns a couple of times so that we have really lots of data there. Now I want to zoom out so that I really push it to the limits. Scrolling itself is still kind of smooth. Let's take a look at the lag radar. Whoop. Yeah, we can see it gets a little bit yellow, but nothing too bad. Maybe let's increase the amount of persons. Once more to 100,000. And as you can see, scrolling is absolutely buttery smooth. Of course, this could be also that my device is quite fast. Let's maybe performance. Let's try adding a slowdown. CPU 4 times throttling. Yeah, and there we can already see the problems with the performance. Where it starts to chug along. So this would be something where we might have to, okay, let's just take a look at how this AD Grid is handling that. Come on, come on, come on. Demo. So maybe let's try to push that one to its limits as well. Oh yeah, we can already see that it's also lagging quite a bit without throttling, because of course you're displaying images here, you have different kinds of things, so really no shame there. Code lag radar. Yeah, you can also see that it's quite yellowy there. And they have this distinction between cheap and expensive rendering, I think. Now maybe let's add the slowdown and see what's happening then. Oh, this is interesting. So they seem to really be rendering incrementally. So when I scroll somewhere, you see that the elements start to come in from the bottom to the top. So they are also using some kind of chunking logic to only render the elements one after the other if there's enough time to render the elements one after the other. Yeah, well, here I render everything at the same time because I get these new visible indices. And so everything is rendered at the same time. And it's super smooth as long as this is working. But once the device is too slow, we get this slowdown that really affects our scrolling performance. On Windows, this is even more dramatic, I think, because scrolling is done on the same. I'm not sure if this is browser dependent. Let's check Safari for a moment. Okay, Safari is failing me again. No, that was not what I wanted. So where are the dev tools? Oh god, I have never used Safari, I think. I think we first have to go to preferences and activate the dev tools. Advanced, maybe? Show develop menu in menu bar. Inspect element. Console. Add is not a function. Okay, add is really is a new feature. I think we can remove that. Oh, but it's so cool. Wait. Return items dot length -1. Cannot find variable request idle callback. Oh. So that one is definitely working as well. I wonder why I have no horizontal scroll bar. Is that a Safari problem? Yeah, in Chrome there's a scroll bar. That's a bit weird. Yeah, no scroll bar. Okay. So maybe let's recap what we did today. Because in this last half an hour we can make maybe a short summary. Let's put that a bit better on the screen. Like that, like that. Virtualized grid. And mock data. This is important. But let's start with our goals. So, what did we do today on day 1 of our SolidJS Hackathon journey? First, we started with defining some goals and non-goals. So we want to build this data grid library within this week, and we had to list some features that we want to implement and some principles that we want to adhere to. So, for example, we have this performance criteria where we want to be able to really render thousands upon thousands of rows without our grid really having any problems with that. We discussed if we want the data and the aggregations to happen on the server side or on the client side, where we decided that the focus for now should be on the client side. So our aggregations, groups, filters, stuff like that will all happen in the browser, with the option that later maybe we could write other adapters that use the same components for filters and groups, but pull their data from the server side. But this is not a focus for this week. Then we decided that we really want to split our calculations so that we are not blocking the main thread, because we have lots of data. Where we are doing expensive filter calculations, then we don't really want to do those filters on the main thread or in one giant chunk, because then we would just block the interaction, so users could no longer scroll, could no longer click on buttons and stuff like that. And there we want to pull the calculations over multiple frames so that the browser has enough time to re-render, to interact with the user and stuff like that. So we will use the basic setup for the Solid app, so the Vite bundler with Typescript. And since somebody asked about testing, we will just take a look at if there comes some stuff up that is really test-worthy, so to say. But we will have to see if there's really a lot of those calculations and if we really need those tests to improve our velocity. Then we talked about different kinds of features or concrete features that we want to in our data grid to be present. So as we already talked about in the last hour, we want this pinning of rows, so rows that are frozen at the top, or I think frozen are they are called frozen areas in Excel. So that we have frozen areas on the left, on the top, on the right, and on the bottom, and that you have this scrollable area right down in the middle. So this is definitely something that will be that will keep us busy, I think, for the first part of tomorrow. Let's check what we can do that later. But this will be, I think, the first part, so that we can have frozen areas on the left, on the bottom, etc., in our data grid. Filters and sorting, filter sorting and grouping, those are the basic features that we really want in our application, that you have filters up top where you can filter the data, that you can resize columns. That's another basic feature that I really want. And we want those groups. So for example, we want to group the persons by their country. so that you can then group and aggregate to gain insights into the data. We want exported to Excel, copy paste. This is all something that might come later. Same with charts. Charts is really something that I don't think we will be able to accomplish within this small week. And we spread those tasks upon the week. As you saw today, we just worked on our visualization of our table component and already got quite far. So we have this grid application where we can generate data, and we have right now, I think, let me check. We are rendering 100,000 rows to the user interface, and scrolling is absolutely no problem at all. The user interface really has no problem with that at the moment. So tomorrow we definitely will start with the rest of the virtualization, so the frozen rows, frozen columns, and then we will start with the base setup for the data grid. So the base infrastructure to define columns, to define items with our grid that we can then pass down to the virtualization library. I think column resize is definitely also something that we are going to do tomorrow, and sorting I think should also be quite an easy one. So I think we are still on track in our current timetable. So maybe let's talk about the code we wrote. So we first started out with our virtualization library. So we built this virtualized grid that is just there to render a bunch of rows and columns. So this grid itself, it doesn't know about headers, it doesn't know about grouping rows or filters or stuff like that. It just gets a list of rows and a list of columns, and it throws these lists and columns and rows on the screen in a virtualized and performant way. So this will be our baseline where we can add a next layer for our logic of our grid application. So far we have this dump virtualization library that we just added to the application to have some testing grounds. And we developed this auto sizer so that this application can always get the full screen, for example, 100% height, 100% width, so that you don't have to specify a fixed width and fixed height there. So far the interface looks like this. We have this virtualized grid. We specify width and height. We specify a list of rows and a list of columns and functions to calculate the width and the height of elements. So maybe let's try something else. I just wanted to implement some kind of a zebra pattern. We can do it like that. P-node ID modulus 2, then 30 and otherwise 50. And now we have rows in some kind of a pattern where one row is large and other rows are small. So we can see it's absolutely no problem for our grid to have dynamic height and dynamic widths of elements. And this up to 100,000 rows, so really no problem. Maybe let's try adding one more zero here. And let's see what's happening. Yeah, so the loading took a bit, but the scrolling itself, absolutely no problem. I had to scroll on a larger screen, on a larger monitor. But of course, this could also be the fact that my machine is quite powerful. We will have to see how that performs on slower machines or when the rendering is a bit more expensive. But this is working quite good so far. So we can pass in these columns, these rows, functions to calculate the height and the width of each of those cells, and we have the cell renderer. So it just gets via props, it gets the current column and the current row, and has to render this element. Do I even get the... Yeah, I get the column and the row. Oh god, perfect. So maybe I don't even need that. I just see props.column, props.row. Yeah, much better. So we can then define when how our cells are going to be rendered. So tomorrow then we are going to hook into this mechanism to decide, do we want to render a header cell? Do we want to render a group cell? Do we want to render a body cell, etc.? So there we can make our style adjustments, while the virtualized grid is just there to render dump data inside of this grid component. So maybe let's add a to-do for day 2. Wait, let's just add in that inside of the table. Oh no, that is the first estimation. On day 2, we want to add frozen areas in Virtualized Grid. Column resize. So there I really want you to have drag and drop so that I can click here and drag the column sizes to change that. I think this should not be too hard to implement. So this is definitely something that I want to do. And I'm not quite sure if we can do sorting. Maybe let's add before that the header menu, where we have to take a look at how we are going to render the tooltip. So when we're clicking here, we want to open this tooltip or this popover menu. And there I'm not quite sure if we are going to build that by ourselves or if we're just using the solid Bootstrap integration. I'm not really sure how we are going to do that. But then when we have this header menu, sorting itself should absolutely not be a problem to accomplish. I think sorting is something there we definitely won't be adding our chunking logic. So this it's definitely going to be something where we are just sorting the list, and if it takes long, it takes long. But this might be something where we might implement a sorting algorithm by ourselves so that we can then apply our chunking logic to spread the calculation across multiple frames. Maybe we are going to even to write a signal where we can calculate derived data in this chunked way, but we will have to see if and how we are going to accomplish that. I can see already some problems with the dependencies that are not tracked, but we will see that at a later point in time then. Okay. So for tomorrow, frozen areas in our grid, column resize and header menu. These are basically the targets for tomorrow. And I think it might definitely be possible to accomplish all of these, because today we spent a lot of time on the chunking itself and the algorithm for the visibility of the rows. But the most important and the most complex part definitely will be the frozen areas for tomorrow. Okay. Then I guess we will wrap it up for today. Thanks a lot for watching. And if you're still tuned in, then again, thanks for watching the whole stream. And I hope that we will see each other tomorrow. Again, same place, same time, 13 o'clock, where we're going to start with day 2 of our SolidHack hackathon. So I guess all that's left to say is have a good evening, and I hope that I will see you tomorrow. Bye.